This is R.D. Sharma solution class 12th chapter 9 continuity MCQ multiple choice question. The function fx is equal to this one. So there are four options and we have to tell it is discontinuous at 1 point, 2 point, 3 point. For that you just have to check what is the denominator in this case. For example, if fx is given like this, 4 minus x squared divided by 4x minus x cube. So any function, when it is valid, when it is not giving you the form of this 0 by infinity, 0 by 0, infinite by infinite, or infinite by 0, these are certain examples that we don't want this kind of thing because it is not describable. For that we have to see the denominator and we have to see what value does this gives so that it becomes valid. So I am taking x common from the denominator. So 4 minus x square, 4 minus x square. So you will be tempted to cancel these two. So only 1 by x will remain. So the answer will be only x should not be equal to 0. This is one point. So you will be tempted to answer the first one. But it is not like that. What we have to do is x is not equal to 0 is one case, but 4 minus x square can also be 0. 4 minus x square cannot be 0, otherwise 0 it will be there in the denominator. So 4 minus x square equals 0 has to be taken care. So when is 4 minus x square equals 0? When x is equal to plus minus 2. So there are 3 points, 0, plus 2 and minus 2. How many points are these? Count these are 3. So fx is defined and continuous for all real number except these 3 points, 0, plus 2, minus 2. So this fx is discontinuous exactly at 3 points which I showed you. Now this question, we have fx is equal to mod x minus a phi x. Now phi x is already given in the question that it is continuous function. So which one of these is okay or perfect? Because a plus in any number line, if you are talking about a plus, we are just adding a very small number, very infinitesimal small number, a plus h. H is that tends to 0. A minus h on the left hand side. Since we have this as f dash, so what we'll do here, we will try to find out the differentiation or f dash using the first principle. So f dash a plus, let us see what we get. So wherever a is there, x is there, just put it as or replace it with a plus h. So limit h tends to 0. So the first principle, it will be fa plus h minus fa divided by h. So wherever x is there, just replace it by a plus h. So here we have a plus h minus a, this is phi x. So just write a plus h in place of x minus, now in place of x just replace it by a, so mod a minus a and phi x, and divided by h. I am not dividing it, we'll just solve the numerator and then we'll see. A minus a is 0, so this whole goes 0, this term you can eliminate. Here you get mod h, and then we have phi a plus h, right? Now mod h, so h, because h is a positive value, we are talking about a positive value, so mod of positive value will be positive only. So phi a plus h it will be. Now we have the h in the denominator and let us apply the limit now. But h gets cancelled. So phi a plus h 0 in this. So phi a will come. And phi a is continuous already given in the question. So the first thing is this one. This one is the correct. We have to check others also. We have to check the others also. For example, the f dash a minus we are going to find out. A minus is wherever x is there, just put a minus h. So limit h tends to 0, fa minus h minus fa and divided by h. So a minus is simply a minus h. H is a very small positive value which is subtracted from a. And divided by h, this is the first principle. Replace x by a minus h. So a minus h minus a, phi, in place of x replace it by a minus h, and then we have minus mod a, just replace it by a minus a mod a minus a, and phi a. Now I am not writing the denominator, first you see here. A minus a is 0, so just cancel it out. So what do you get? Mod minus h and phi a minus h. Now you see very carefully, denominator you have h. Now this is mod minus h, but h is a positive value. As I said, h is a positive value. So what do you get? It has to be x is mod x. When x is greater than 0, it is mod x is x. When x is less than 0, it is negative x. So when we are talking about the modulus of minus h, it will give you a negative value. Right? You can always think like that, minus 1 into mod h, it is positive. So in this case, when we are dealing with h and the variables, not the values, when we are dealing with the variables, you have to see if x is greater than 0, it is x. If x is less than 0, it is negative x. So here it will come as negative. So minus phi a minus h will be a minus h. Okay, let us apply the limit now. Limit h tends to 0. So this is going to be 0 minus phi a. So what is this? This is your second thing which is true in this case. There are two things which are correct here. Now fx is equal to modulus of log base 10x. Then at x equals 1. So we'll check this at x equals 1. So we'll try to resolve it first, because you need to know about logs. How do they behave? And then only you will be able to solve this type of question. So we'll resolve it. This fx is given as log base 10 is an x. So you can write it like this. Take the base as e. So it will be log base ex divided by log base e 10. This is how you can write. Okay. Now this is a constant, and when you take it in the numerator, log x will remain like that, and then this 10 and e will replace their places. So log 10 e it will be, and this is a constant, so you don't have to deal with this. It will be a positive value. 10 to the power something is e. 10 to the power something is e. So assume it that this is a constant. I will take it outside and try to find out what we get. Okay. But log ex, here we are going to apply the f dash x. So f dash 1 plus, because the question is asking about that. So when you are talking about 1 plus, you have to replace it by 1 plus h. X by 1 plus h. And for the other side, it will be 1 minus h. So f dash 1 plus means 1 plus h you are applying here. So f 1 plus h minus f1 by h, limit h tends to 0. So we'll talk about limit h tends to 0 and denominator h later. First let us solve this. So 1 plus h, in place of x just replace it by 1 plus h. This constant I am not dealing, because it is a constant, it will come outside. So we don't have to write it again and again. Just assume that this constant is there and we can take it outside. Let us talk with log base e 1 plus h. And this is in the modulus, minus log base e, and then we have 1 here. 1. And log 1 for any base is going to be 0. Please remember, it is basically e to the power something which is equal to 1. So e to the power something, anything to the power is 1 when the anything is, the power is going to be 0. So this is 0. Log base e 1 or log 1 is simply 0. Just replace it or eliminate it. So we have log base e 1 plus h, and in the denominator we already have a h, and limit h tends to 0, and we know that log 1 plus h divided by h, limit h tends to 0, is going to be 1. So this whole, if you apply the limit, this is going to be 1. Now I told you already that log e to base 10 was a constant, so it was outside. So finally the value will be, because only 1 has come and constant was already there, log base 10e. So log base 10e is the final answer, right? This is a final answer. Okay. First one you are getting, but we have to check for a log 1 minus also. So I am just clearing it, and we are coming on this second part, which is f dash 1 minus. So you have to replace this x by 1 minus h. So just replace wherever, basically it is f1 minus h minus f1 by h. Replace x with 1 minus h. So remember, when we resolve it, or you can say that log 10x, we wrote it as log e log x. Log e base was 10, log x base was e. But log e base 10 is a constant. So you can just forget it for now. Just assume that it will be outside. We are dealing only with log x. So log x means, and base is already e. So log 1 minus h, x is replaced by 1 minus h, minus f1. So replace x by 1. So log base e 1, and take the modulus here. Okay. Log 1, as we just talked about, log 1 is 0. So replace it by 0 or remove it. Now log base e 1 minus h. Now as we know, log 1 plus h by h is equal to 1 when we apply the limit h tends to 0. But since we have log 1 minus h by h, so what do? We can assume this 1 minus h, or we can write this 1 minus h by 1 plus minus h, and the denominator is h, so you need a negative h. So multiply numerator denominator by minus 1. I hope you got the idea. We need to get log 1 plus h divided by h, and limit h tends to 0 is going to be 1. But since we don't have 1 plus h in the numerator, so we just need to use some trick. The trick of solving this is simply, you can write the numerator as log base e 1 plus minus h, and the denominator as minus h. And since you have introduced a minus, there will be a negative in the numerator also. So let me write it as 1 plus minus h. Okay, and denominator also you have minus h. 1 plus minus h, and denominator also negative h. Okay. So minus h it is there, and minus a negative will be always there because you have introduced negative by yourself. Okay. Let me tell you again. Log 1 plus h by h is 1. We are not getting log 1 plus h here. So log base e 1 plus minus h we have done. And since the denominator only has h, we need a negative h. So you need to multiply numerator denominator by negative 1. Okay. Now limit h tends to 0. This is the whole form which we wanted. And just assume it to be 1 plus say k or x, because 1 plus k by k, limit k tends to 0 is also 1. Only negative has come. And as I told you, the constant is already there. Log base 10e. So minus 10 minus log base 10e. So what is the answer here? This one. The last one. So what is the answer here? This one is correct, and this one is also correct. There are two things which are correct here. So this question, let me just write those things just to recall you. That limit extends to a fx. If it is equal to fa, then we say that this at point x equals a, or at x which is equal to a, in this case it is 0, f0. So this is continuous. So this is equal to k, in this question it is given. this whole scenario is, because it is continuous at x equals to 0, x is tending to a. So what we'll do is we essentially have to find out the limit of the first function, because this is equal to f0. F0 is k here. So we will find out the limit, and this is basically not a continuity question. It is basically finding the limit question. So we'll take the numerator first. 36 raised x minus 9 raised x minus 4 raised x plus 1. This is the numerator, and I'm just indicating it with n. Denominator I'll take later. How to do this? 36 raised x is, 36 can be written as 9 4s or 36, 9 4. And to the power x, which is 9 raised x dot 4 raised x 4 to the power x. Just put it here, 9x into 4 raised x minus 9 raised x minus 4 raised x plus 1. So 9 raised x you can take common, 4 raised x minus 1, and here minus 1 common, 4 raised x minus 1. So 9 raised x minus 1, 4 raised x minus 1. Okay. Now let me tell you the formula or a relationship, that is limit x tends to 0, a raised x minus 1 by x, and this is equal to log base e a. So log base e, we generally write this as ln. Log base is ln, so ln a. So just divide it both by x and x. So since we have divided by ourselves, we have to multiply by x also. And now apply the limit. So limit x tends to 0 here. Here also limit x tends to 0. So this first one will be what? A raised x minus 1 by x. It will be log 9. So as I said, log can be written as ln. So ln 9 multiplied by ln, that is log base e, is 4. Now 9 can be written as 3 squared. 4 can be written as 2 squared, and in log the power comes outside. So 2 ln 3, and here 2 ln 2. Okay, 2 to the 4 here, 4 ln 2 ln 3. So log 2 log 3 we can write. So log 2 log 3, we have come across one of the option which is matching with it. This is the numerator. Okay, 4 log 2 log 3, and since we have this x square also we have initially introduced, so it's 4x square log 2 log 3. Now coming to the denominator, this numerator we have already done. Denominator is root 2 minus under root 1 plus cos x. Okay, so root 2 1 plus cos x can be written as 2 cos square x by 2. So when you take the root of this, it will be under root 2 cos square x by 2. So it can be written as under root 2 multiplied by under root cos square x by 2. So under root 2 into cos x by 2 it is. So root 2 you can take common, 1 minus cos x by 2 it will be. Okay. 1 minus cos 2 theta is 2 sin square theta. That is, wherever you have this theta, you can just make it half and keep it with sine. So 2 sine square, since it is already x by 2, we have to divide it by 2. So x by 2 is 4. So this is sine x by 4. So you need to introduce sine x by 4 in the denominator also. So let us introduce the x by 4 whole squared here. So you have to multiply x by 4 whole squared. So this whole term is simply sin x by 4 divided by x by 4, and it will be square. But it is limit x tends to 0. So sin theta by theta, limit theta tends to 0 is 1. We know already that. In the previous question already we have seen. So this is going to be 1. So what is remaining? It's 2 root 2, and this is x squared by 4 4s are 16. So you can cut it like this, 2 8s are 16, x square, 2 root 2 x square by 8. Now remember, this was the denominator. What was the numerator? It was 4x square log 2 log 3. Now you can cancel this x square, and 8 you have to take it in the numerator. So it goes up. It is 8 into 4 basically. So 8 4s are 32 it is. So 32 log 2 log 3 and divided by root 2. So multiply numerator denominator by root 2 just to eliminate root 2 from the denominator. So root 2 will give you 2 and 232, so it will be 16. This is 2, 16. So 16 root 2 log 3. So now the first option is exactly matching with it, and that is going to be your answer. Okay, and let me tell you, it is third option, ln. Okay, not the first option, third option. Okay, now question number 5. So fx is continuous for all x, and we have the point of contention as x equals 0, x is equal to 1, x. For that, in this type of question, we have to really understand the concept of modulus. So this is a number line, and there are 2 points, 0 and 1. So x is 0 and 1. If it is not equal to 0 and 1, it will be this, x square minus x by x square minus x with modulus. And when x is equal to 1 exactly, we have to take fx as 1. When it is 1, when x is 1, we have to take it as negative 1. So fx is equal to negative 1. Okay. So main thing is this one, mod x square minus x by x square minus x. So what do you get here? And this, there are various boundaries, minus infinity to 0, 0 to 1 and 1 to plus infinity. So fx will make it 1 by 1. Because at 0 and 1, the values are 1 and minus 1. But when it is 0 and when it is not equal to 0 and 1, we have, so when it is not equal to 0 to 1, we have to take the boundaries. So this is mod x square minus x by x square minus x. So you can always write this x square minus x as x into x minus 1. Denominator also you can write x square minus x as x into x minus 1. But modulus is in the numerator, so you can separate the modulus also. This can be written as mod x multiplied by mod x minus 1 divided by x into x minus 1. Okay. So mod, you have to really concentrate on the modulus. When x is greater than 1, when x is greater than 1, mod x, for mod x simply, when x is greater than 0, it is going to be x. When x is less than or equal to 0, it will be negative x, right? We have to just replace this value depending upon whether x is less than 0 or greater than 0. But x minus 1 is also there. So when we are above x equals 1, x is positive and x minus 1 will be positive. Because as x is dividing negative positive at 0, x minus is dividing negative and positive at x equals 1. So both are 1. Means both are non-negative, that is positive. So this both cancels and it will give you 1. Now second thing is x is less than 0. So when is x is less than 0, it will be negative. And x minus 1 again, mod x minus 1 is when you have less than minus 1. Well, less than 1, it will also be negative. Okay, when it is less than 1, it will be negative x minus 1. We are talking about x less than 0. So negative x will give you negative, x minus 1 will also give you negative. For example, I am just taking a value, say negative 1. So it will be negative 2. Minus 1 is negative 2. So minus x and minus x minus 1, if you remove the modulus, denominator you have x and x minus 1, you can cancel these. Minus is plus. So if x is less than 0, then you get both numerator denominator as equal, negative cancels out. So this is also 1. I hope you got the idea. This is the whole crux of this question. Now let us see what is between 0 and 1. If it is between 0 and 1, so the x will give you positive when you remove the modulus, and x minus 1 will be negative. Why it is negative? Because x at 1, it decides for x minus 1 whether it is positive or negative. So this is the boundary of x. Right side it is positive, left hand side is negative. But x, when it is greater than 0, it is going to give you positive value. So x and minus x minus 1 will be there. Denominator you have x into x minus 1. So you can just cancel this, you will get negative 1. So negative 1 you have x between 0 and 1. And this please remember, so we are talking about x equals to 0, which is already given in the question. X equals 1 is also given in the question. So there are multiple boundaries, multiple points. So we will try to combine all these. What is happening in these boundaries? Because they are separate values, some values are given. So we can just replace this equality sign and take it with the less than or equal to sign. So x is greater than 1, x equals 1, both are different, so we cannot combine them. X is less than 0, x is between 0 and 1, and x is less than 0, it is 1 minus 1. So x is less than 0, it is less than 0 and it is equal to 0. So both are 1. So you can combine these two. X is less than equal to 0. So I have combined less than and equal. X less than 0 and x equal to 0. You can combine these two. And since it is equal to 1, we can just write 1. How about 0 and 1? Between 0 and 1? So you are getting minus 1. So you can combine that x between 0 and 1 inclusive. So final fx is like this. 1, if you go up 1, you get 1. X is less than or equal to 0, you get 1. And between 0 and 1, where 1 is inclusive, is negative 1. I hope you got the idea. Now this is quite easy. You don't have to go for left hand limit and right hand limit, because it is picture clear that whether it will be continuous at point or not. So now we'll actually check 0 and 1. 0 and 1 point we are going to check actually. How? Just see. So if you have 0 and less than, you add 0. If it is less than 0 or equal, it is 1. But when you just move ahead of 0, above 0, it is negative 1. So at x, you can say that at 0 you can take 0 minus or 0 plus, that is left hand limit, right hand limit. But we see here that at left side it will be 1, on the right hand side it will be negative 1. So the left hand limit and right hand limit will not match. Okay, in proper continuity scenario, you have to write limit fx, x tends to 0 minus, then you will get a 1. When you apply limit x tends to 0 plus fx, it is going to be negative 1. But they both are not equal. That means when they are not equal, that means the function is not continuous at this point. At 0, it is not. Again, at 1 will do the same thing. So 0, it is not because it is not matching. Let us see the 1. At 1, that is x greater than or it is 1, it is 1, and x less than or equal to 1, it is going to be negative 1. So when you check limit x tends to 1 plus and x tends to 1 minus, both are not same. Okay? They both are 1 and minus 1, they are not equal from this final combination I made. Or you can write the limit also, just like 0. So 1 is 1, 1 is minus 1. So it is not continuous at 0 or 1. So you can just write this answer. Remember previous question we just talked about? It is not the option first, it is ln option. So both 1 and 0 you have to write, and this is how you have to do it, because this left hand limit, right hand limit, I already showed you. 1 minus h, 1 plus h you have to write, 0 minus h, 0 plus h you have to write, and just because these are constant values, constant will come, right? Now this question x, the point is pi by 2. When the point, the f a, which is f pi by 2 is equal to k. And we know that when we have f pi by 2 or f a, and this is given as k, and this is equal to nothing but limit x tends to pi by 2, and then this x tends to pi by 2, we have to take this all function, right? Let us write it as fx. So we have to find out the limit of this function at pi by 2, and we just have to equate it with k. The value of the limit will be equal to k. I hope you got the idea. In totality, the question will be solved by finding out the limit of this function at x equals pi by 2. So this is the solution just for your reference. If you are able to solve yourself, then it is okay. But we are going to do it by ourselves. We will take one by one term. Every term I am going to take separately, because it will take, this is always a good idea not to combine all of these, because there will be some confusion. So in left hand limit, right hand limit, what do we do? Pi by 2 minus h and pi by 2 plus h. Since it is already given in the question, it is continuous at x equals pi by 2. So left hand limit and right hand limit will be equal. So either you can try with pi by 2 plus h or pi by 2 minus h. I am doing with pi by 2 minus h. Okay. So the limit, every time I am going to apply this limit, h tends to 0 because x is tending to pi by 2 minus h. 1 minus sin x will start with the first term. 1 minus sin x is what? We have to replace first x by pi by 2 minus h in each and every question. So 1 minus this x is replaced by pi by 2 minus h. So sin pi by 2 minus h, and sin 90 minus theta is cos theta. So it will be 1 minus cos x. Okay. Now 1 minus cos x can be written as 2 sin square. It is h actually. 2 sin square h by 2. Do 2 sin square h by 2. H by 2 is with h. So 2 sin square h by 2. So we have to introduce h by 2 whole square, that is h square by 4 in the denominator and numerator. Why we are doing this? Because we know sin theta by theta, limit theta tends to 0 is equal to 1. So it will be 2 sin h by 2 by h by 2 whole square. So let me remind you again. Limit theta tends to 0, sin theta by theta is 1. This is all going to be 1 and multiplied by h square by 4. So 2 into h square by 4. 2 gets cancelled. You get h square by 2. So please remember what all terms are giving you. The first term is giving you h square by 2. Now coming to the second point, which is pi minus 2x whole square. Pi minus twice of x whole square. So we have to replace this x by pi by 2 minus h. So pi minus 2 into pi by 2 minus h. And we'll square it later. Let us solve it. Pi minus 2 into pi by 2 and plus 2, that is 2h. This 2 gets cancelled. Pi minus pi is 0. So only 2h remains. So it will be 4h square because it is square. First term gave you h square by 2. The denominator gave you 4h square. So let us solve it here also, or you can take all other two terms. So the first term is h square by 2 and denominator you have 4h square. H square gets cancelled. You get 1 by 8. So the first term is giving you 1 by 8. We'll use it later. Coming to the third term, which is log sin x. Let me just change the color so that you understand. We are taking each term separately. Now I am taking log sin x. So sin x will deal with sin x. Sin this, you have to write pi by 2 minus h in place of x. Sin pi by 2 minus h. So it is cos h. Sin 90 minus theta is cos theta. So cos h is under root 1 minus sin square h. Because sin square theta plus cos square theta is 1. Cos h you can write it as under root 1 minus sin square h. Okay, now log. So there will be log 1 minus sin square h, and this can be written as under root is simply power raised to half, and in log always half the power comes outside. So half log 1 minus sin square h. So there are certain questions which have the same formula being used, because log 1 plus x by x, limit x tends to 0 is equal to 1. So we have log 1 minus sin square h, so you need a negative sin square h in the denominator. So when you are including, because you can write it as 1 plus minus sin square h divided by minus sin square h, so that it matches the formula. So why we have this minus sin square h in the denominator, you have to have negative sin square h in the numerator also. So this whole is limit h tends to 0. When you apply, it is going to be 1. So you are left with half into negative sin square h. This is what log sin x has given you. coming to the last term, which is log 1 plus pi square minus 4 pi x plus 4x square. So let me change the color so that you understand this is the fourth term we are dealing with. So log, I'm not writing log, I'll just write log later. It is 1 plus pi square minus 4 pi x plus 4x square. Okay. Now 1 plus pi square minus 4 pi, in place of x write pi by 2 minus x, plus 4x square, in place of x write pi by 2 minus x whole square. H, it is pi by 2 minus h. So 1 plus pi square minus 4 pi into pi by 2, and minus minus become plus 4 pi h. Okay, here it will be 4. Now open this, a minus b whole square. So pi by 2 whole square, pi square by 4 plus h square minus 2 into pi by 2 into h. 2 into pi by 2 into h, 2 gets cancelled, you get pi h. Now this 1 plus pi square, 2 gets cancelled, so you have minus 2 pi square. Minus 2 pi square plus 4 pi h, and just multiply this, 4 gets cancelled, pi square plus 4h square minus 4 pi h. Now this gets cancelled. Pi square plus pi square is 2 pi square, minus 2 pi square is there, so these all pi square gets cancelled. So you are left with 1 plus 4h square. Please remember it is inside the log. So log 1 plus 4h square. So again log 1 plus by x, 1 plus x by x. So you can include, they introduce 4h square in the denominator, so you have to have a 4h square in the numerator also. So limit h tends to 0, this whole is going to give you 1. And you have 4h square here. Now minus half sine square h. Okay, now let us take the all terms. So minus half log sin h gave you minus half sine square h, and in the denominator you have 4h square. 4h square. Okay, so this 4h square, you can sin h by h whole square it is, and you know that sin theta by theta, limit theta tends to 0 is 1. So minus 1 by 8 will remain. And remember, this is the second term. Now remember you had already 1 by 8 for the first two terms. So 1 by 8 into minus 1 by 8 is going to be minus 1 by 64. So this is equal to k. K is negative 1 by 64. That is the answer of this question. If fx is equal to x plus 1 raised to the power cot x be continuous at x equals 0, then f0 is equal to. Now you have to have a fair idea about log, then only you will be able to solve this. So limit extends to a fx, this I am telling you about the continuity. If it is equal to fa, in this case a is 0, so limit extends to 0 fx if it is equal to f0, then f0 is equal to what? So we have to actually find out the limit here. Limit extends to 0 for x plus 1 to the power cot x. So let us see how we do it. There are two methods actually. So I'll tell you both the methods. Fx is equal to x plus 1 raised to the power cot x. So let us take the log. So log fx is equal to cot x. When you take the log, the power comes in front. That is, it will be cot x log x plus 1. So log x plus 1 raised to the power cot x will be cot x log x plus 1. So log fx is equal to cot x, then log, then x plus 1. Okay. Now this cot x can be written as 1 by 10x. And please remember this cot x is in front of log. So cot we can write it as 10x. So it will be log x plus 1 and divided by 10x. I'll just replace it by 10x. Now remember that when you take the limit of the log, the limit goes inside. That is, we have to apply the limit. That is what we are finding. So limit extends to 0 for log x. It goes inside. So this will be log, limit extends to 0, fx. When you apply limit here, so there will be two, equality or trigonometric identities. That is, log 1 plus x by x is equal to 1 when the limit of x tends to 0. The second will be 10x by x, limit x tends to 0. This is also equal to 1. Alright. So when we apply the limit here, just assume that I have written limit. So log 1 plus x, now we have to divide it by x. So we have to multiply it by x also. And what about the tan x? So this is actually tan x because cot x we have brought down to the denominator. So tan x, you divide by x, multiply by x. Now what do you get? You get this cancelled. So log 1 plus x by x, as I just told you, it is limit x tends to 0, it is going to be 1. Limit x tends to 0, tan x by x, this will also be equal to 1. So eventually what do you got? So you get 1. And this is log limit x tends to 0 fx. So this is basically something to the power 1 is limit x tends to fx. And since the base is e, the log base, we assume it to be, because we have taken the log, not base 10 but base e. Normal default value of log base is e. So e to the power 1 is equal to limit fx x tends to 0. So basically log base yx is nothing but y to the power 1 is equal to x. So in this case the base is e. So e to the power 1 is equal to limit x tends to 0 for fx. As I told you earlier that you need to have a fair idea about the logarithm, then only you will be able to understand this. So log base is e. Now e to the power 1 is limit fx x tends to 0. So this is e. The answer here is limit x tends to 0, fx is e. So f0 is e because basically f0 is what? The limit. As I told you, it is basically the limit. Now log and there is another method also. As I said, there is a simple method. Most of the time we generally avoid log, so we have a separate solution. The solution is very simple because ultimately you have to find out the limit x tends to 0 for fx, which is x plus 1 to the power cot x. So what we will do here is we'll just try to make the expression so that we get a simple limit and solution. So x plus 1, that is 1 plus x to the power, this is 1 plus x to the power 1 by x, and then you have x cot x here because x gets cancelled. We have introduced this x, that is why we have to write x cot x also. Okay, now this is 1 plus x to the power 1 by x, and then this is x by 10x, cot x is 1 by 10x. When you apply the limit, now please remember, if you know the limits, limit 1 plus x raised to the power x is e. So that is how the answer comes. Now if fx is equal to this, log 1 plus ax minus log 1 minus bx by x when x is not equal to 0, and it is equal to k when x is equal to 0. So limit x tends to a, fx is simply equal to fa. A is 0 in this case, in our case. So x tends to 0 it is. So this above function, which is not equal to 0, lower x equal to 0, which is k. So eventually we'll equate it to k only. We have to find out the limit. This is the only thing you need to keep in your mind. So limit x tends to 0. You have log 1 plus ax minus log 1 minus bx, and this is divided by x. So you can just separate it because the denominator is common to both of the above terms. Log 1 plus ax divided by x minus log 1 minus bx divided by x. Please remember, as I told you earlier also, log 1 plus x divided by x, limit x tends to 0 is equal to 1. So since we have ax, we have a in the denominator, numerator also we introduce. Since it is minus bx, so you can have a b minus b here, multiplied by minus b in the numerator. So let us apply the limit here. We are applying limit both the sides. So this is simply log 1 plus theta by theta, or log 1 plus ax by ax. This is going to be 1. log 1 minus bx divided by minus bx. This is also equal to 1. So a minus of minus b, that is a plus b, has remained, and that is equal to your f0, which is equal to k. Now this question, fx, the e raised to the power 1 by x minus 1, e raised to the power 1 by x plus 1. So continuity and discontinuity we have to check. So limit x tends to 0. Above function, let us call it as fx, and this is equal to fa, which is a is 0 in this case. So we just have to find out the limit of this e raised 1 by x minus 1 divided by e raised 1 by x plus 1, and then we'll check the continuity at 0 or not. So this is there are certain ways you can solve it. If you know about the limits, it's quite easy for you. Limit x tends to 0. We have e 1 by x minus 1 divided by e raised 1 by x plus 1. Now you just take this term, call it as some t or some p, whichever you want. I'm taking it as p's, for example. So it will be p minus 1 by p plus 1. So p minus 1 by p plus 1. When x is tending to 0, so 1 by x will be tending to infinity. So e to the power infinity it will be. So if e to the power infinite, anything to the power infinite is infinite only. So p is tending to infinite. So infinite minus 1 by infinite plus 1. So this will not be a proper way of solving it. So we'll try to resolve it. We'll try to get certain solution which is feasible. So limit x tends to 0. Now divide both numerator denominator by p, that is e raised 1 by x. We are dividing numerator denominator, that is e raised 1 by x, which I just called as p. So I'm doing it numerator denominator. So e raised x 1 by x by e raised 1 by x minus 1 by e raised 1 by x. Here also e raised 1 by x divided by e raised 1 by x plus 1 by e raised 1 by x. This is 1 minus 1. So 1 by e raised 1 by x. Now see here. I'm just replacing it by p. I'll just show what will happen. So I just told you that it is going to be infinity. When you apply limit, this p tends to infinity, what it will be? Infinity, 1 by infinity is 0. When you divide anything by infinity, it will be 0. If you divide any number by a huge number, a very huge number, it will be 0. So 1 minus 0 by 1 plus 0. So you get 1 by 1, that is 1. But this 1 is when the x is not equal to 0. And you get 0 when x is equal to 0. So 1 is not equal to 0. So it is not continuous. So I indicated you earlier that it may not be continuous. It may be made continuous. That is not the case. It is not continuous. That is the answer because we have devised it. Fx is x minus 4 divided by x mod x minus 4 plus a, and when x is less than 4, similarly x greater than 4, same term with the b, and a plus b when x is equal to 4, then fx is continuous at x equals 4. So we have to find out the value of a and b. Okay. So this type of question we have done multiple times, but still we will try to complete it for the sake of completion. Okay, so limit x tends to a, fx equals f a, this is continuity, a is 4 here, so limit x tends to 4, f x you have to find out, and that has to be equal to f a, which is a plus b. So this is the number line. 4 we are going to check. If you go to the left, you have to put x as 4 minus h. If you go to the right, you have to put x as 4 plus h. Okay, 4 minus h and 4 plus h. So this is what we have to use. And the value of the x is equal to 4, so a plus b. F4 is already a plus b given in the question. Now, let us see what we can do here. We will try to do the LHL and RHL, left hand limit and right hand limit together. X we have to place and 4 minus h, x equals 4 plus h in case of LHL and RHL as I indicated you. X minus 4, I am replacing it now. 4 minus h minus 4 divided by mod of 4 minus h minus 4 and plus a. Here you have 4 plus h minus 4 divided by 4 plus h minus 4, and in this case 4 gets cancelled, 4 gets cancelled, minus h by mod of minus h. So this is in negative. So what do you get? You'll get this in, so this is plus a. So a, it will be negative because mod minus h is positive h. So a minus n you'll get. 4 gets cancelled, 4 gets cancelled, h by mod h. Here no problem with negative positive, so you'll get 1. You already have a b along with this, so plus b you can do, plus b. So b plus 1 you get here, and a minus 1 you get here. So this is equal to a plus b. So this is a minus b, 1 equal to b plus 1, and this is equal to a plus b. Now I hope you'll be able to solve this. A will come as 1 and b come as minus 1. Let us do it. A minus 1 equals b plus 1. So this is a equals b plus 2. So we'll replace this a equals b plus 2 in any of the equation. You can take any combination. There are 3. So a minus 1 equals a plus b you can take, or a minus a plus b equals b plus 1 you can take. It's up to you. And a, when you take b plus 1 equals a plus b, it's eventually you're going to get a equals 1 because bb gets cancelled. You can do it this way also, which I am doing. So there are multiple ways. So a is actually 1, and just put it here. So when a is 1, just put it in b plus 1 equals a minus 1, you'll get b as minus 1. So this is how we get the answer. So this question, we have actually 2 solutions here. So whichever you want to follow, you can follow that. The concept is same in both of these solutions. Okay, one of them I am going to tell you, and second one I showed you. So basically, limit extends to a, which is actually 0 here, fx. So when you are taking x tends to 0, you will take, because it is not equal to 0, so you will take cos x raised 1 by x. It is equal to fa is 0, f is 0, which is equal to k. So the limit has to be equated to k. So cos x 1 by x, cos x raised to 1 by x. How are we going to solve this? Cos x 1 by x. So when we apply the limit, the one method is to take the log. The second method is to take the direct identity, direct relation. So a cos x is fx and gx is 1 by x. So cos x, when you apply x is 0, it is tending to 0. Gx 1 by x, it is tending to infinity. So when you have 1 to infinity form, 1 raised to infinity form, then we have e to the power. See, this result you have to know when you have learned limit. So it is equal to e to the power, limit extends to 0, fx minus 1 multiplied by gx. Sometimes you may not be able to recall these, so then in that case you can use the logarithmic, the concept of logarithm. But if you remember this, you can apply this 1 to the infinity form, so you actually solve like this. Okay, now this becomes very easy now, because we'll be dealing with e later, that is fx minus 1, so cos x minus 1, and gx we have assumed it to be 1 by x, so it will be multiplied by 1 by x, so it will be in the denominator. Okay, let's have limit extends to 0, cos x minus 1 by 1. See, you can always write this is 1 minus 1 minus cos x. You can always write it as 2 sin square x by 2. You always have x. Then you can just have this x included, and you have to multiply the x with the numerator also. You can have 4 here, and then you have sin x by 2 by x by 2 whole square. Limit extends to 0. Sin x by 2 by x by 2 is 1. And then you have a x that you have introduced. So when you apply the limit, it will be 0 because there is an x. X tends to 0, x is equal to 0 is 0. So finally what you get is this value, total limit extends to 0, cos x minus 1 by x. This becomes 0. I hope you got the idea. This is going to be 0 because there is an x which we introduce, which is in the numerator, and that gives you 0. So this becomes 0. So now this is 0. E raised to the power 0 is what we have to equate, k. So it is equal to k. So e raised 0 is k. So what is 1? Anything to the power 0 is 1, so 1 is k. This is also one of the way you can just go through it, but the concept is same. Okay, this question we have already done in the VSAQ 9.2 exercise. Various exercises we have already discussed, and the concept is quite easy here. Since we have done, I'll just tell you how to solve this, because this is MCQ question. Modulus is always continuous. So mod x, if you assume it to be f, it is continuous. Mod x minus 1, if you assume it to be g, it is again continuous. When you add them, f plus g, it will be again continuous. So when it is continuous, fx is continuous at x equals to 0, x equals to 1, because mod x is all about when it becomes 0. So x is 0. X minus 1 is 0 when x is equal to 1. So at x equal to 0 and x equals to 1, it will be. So this is 0 and 1, 2 points. And the answer is that fx is continuous at both these points. You can also, how to do this, I'll just give you an idea. 0 minus h, 0 plus h, you have to find out the left hand limit, right hand limit at 0. Same at 1, because 1 plus h, 1 minus h, for left hand limit, right hand limit, you have to equate it, and you will find out. I can tell you, because we have already done this type of question, so I can tell you that it will be continuous. We have already showed it to be continuous, right? For example, when you really want to find out the value of the function at 1 and 0, so you can just put this value, and that will be equivalent to the value of left hand limit and right hand limit in the case of 1, in the case of 0. So we can just tell that fx is continuous at x equals to 0 and x is equal to 1, right? Now fx is given like this: when x is not equal to 1 and 2, when x is equal to 1, it is 6, x is equal to 2, it is 12. So if then fx is continuous on the set, right? Now you have to concentrate on the first, because you have to check at 1 and 2. So the value is exactly at 6. At 1 is 6, at 2 it is 12. So you have to find out the left hand limit and right hand limit at 6. LHL and RHL at 12. So we will first resolve this what is given, and this will take an effort. Please understand it very carefully. Mod x minus 1 into x minus 2. You can separate them also, mod x minus 1 and mod x minus 2. It doesn't matter. X square minus 5x square plus 4. So we have to find out the factors of this. So x raised 4 and this 4, so you have 4, so you can write it as minus x square minus 4x square. That will eventually be equal to minus 5x square plus 4. You can take x square common, so you have x square minus 1. You can take minus 4 common, you have x square minus 1. So eventually you get x square minus 4 and x square plus x square minus 1. So you have x minus, it can be assumed to be 2 square, x square minus 2 square. So basically what are you going to get? X minus 2, x plus 2. So this is basically a minus b, a plus b, x square minus 2 square, a minus b, a plus b, x minus 2 into x plus 2. In x square minus 1 square, it will be x minus 1, x plus 1. Again, a square minus b square formula we are using. Right. So this will be in the numerator. X minus 2, x plus 2, x minus 1, x plus 1. Right. Now you have to be very careful about where this value x minus 1 into x minus 2 or x minus 1 separately and x minus 2 separately, they are going to be equal to negative or positive. So when you go on the left of 1, what will be the value? Mod x minus 1. See, 1 is the deciding point for x minus 1. Above 1, x minus 1 will be positive. Below 1, x minus 1 will be negative. Right? Similarly, x minus 2, x equals 2 is the deciding point. X greater than 2 is going to be positive. X less than 2, it is going to be negative. Right? So we are talking about x less than 1 now. Let us see. I hope you got the idea. At x below 1, it is going to be negative x minus 1. When it is x minus 2 less than 1, as I said, x equals 2 is the deciding point for x minus 2. So you are going on the left of x minus 2. So will it be positive or negative? What do you think? It has to be Negative, because 2 is the deciding point. You go left, it will be negative. You go right, it will be positive. And what will is the numerator? X plus 2, x minus 2, x plus 1, x minus 1, and x plus 2, x minus 2. Now you can cancel these two. Only the thing will remain is x plus 1 and x plus 2 when x is less than 1. This is for x less than 1. Now you have to check for x greater than 2 also. And you have to check for x in between 1 and 2 also. So what I am doing here is x minus 1, x minus 2. I am writing it again just in case you miss something. So just cancel these two. And x plus 2 and x plus 1. Only positive, that is plus values will remain. But it will be negative in the denominator becomes positive. So first let us do the x greater than 2. Then we'll talk about 1 and 2 in between. So x is greater than 2 we are talking about, it is not 0. I have written it, I'll just correct it. So when we are talking about x greater than 2, so again 1 is the deciding point for x equals x minus 1. 2 is the deciding point for x minus 2. When you are going above 2, both will be positive. When you remove the modulus sign, both will be positive. So you just cancel these out is the same way and you'll get x plus 1 and x plus 2. Now what about 1 and 2? So when you are between 1 and 2, what is the deciding point for x minus 1? So you're above 1, so x minus 1 will be positive. But you're below 2, so x minus 2 will be negative. That is x minus 1 and x minus 2. 1 is the deciding point for positive and negative for x minus 1. 2 is the deciding point for x minus 2. So you get x plus 1 and x minus 2. X minus 2 will be negative. So there will be negative. So you see there is a negative for x which is in between 1 and 2. Okay, let me just reiterate. We solve this. Then we try to find out what will happen to the modulus and to the expression consequently for x less than 1, between 1 and 2, and then x is greater than 2. Okay. So this we have done. Now let us come to the exact point 1 and 2. So we will take the left hand limit for 1, right hand limit for 1. Similarly, we'll do it for 2. I hope you'll be able to do it for 2. I'll just concentrate on this 1. So this is exactly same what we'll do it for 2. 1 minus h. So just put, because when you are going on the left of 1, that is x less than 1, so you will use x plus 1 into x plus 2. So I am replacing x by 1 minus h. So 1 minus h plus 1 and 1 minus h plus 2. This is when you are going to x equals 1 minus h. So you get 2 minus h, here 3 minus h. Now apply the limit. So this will be, you have to write, replace x as 1 minus h, which we already done. Now you get 6. 3 into 2 is 6. Now in between 1 and 2. 1 and 2. So as I said, when you go above 1 and 2, you have to use. So 1 plus h you have to keep in minus x plus 1 into x plus 2. Again, just replace x by 1 plus h. So you get 1 plus h plus 1, 1 plus h plus 2. So 2 plus h you get, and 3 plus h you get. Negative will be there. Now, so you get minus 6, negative 6 here. So 6 and negative 6 are not equal. So left hand limit and right hand limit, they are not equal. So you can very well say that in this case, the values are not matching. So the function is not continuous at 1. Same thing you have to do for 2. X equal 2. Please remember, left hand limit you have to write 2 minus h. Right hand limit you have to write 2 plus h. One time it will come as 12. One time it will come as negative 12, because when you go on the left hand limit, left hand side, it will be negative 12. Let me just do it. Because when you go on the left hand side of 2, you have to use negative x plus 1 into x plus 2, where in the place of x you are going to replace x by 2 minus h. 2 minus h I am replacing 2 minus h plus 1, 2 minus h plus 2, and this will be negative. Please remember, it is negative. So you just replace this, h will be 0. So 3 into 4, this is 12. You have a negative here, so negative 12. Now 2 plus h, when you go up, so 2 plus h plus 1 and 2 plus h plus 2. Again, replace h by 0. It will be positive because it is greater than 2, and we have to use x plus 1 into x plus 2, where we replace x by 2 plus h. So you have this as 4 plus h, just replace h by 0. You get 4 is a 12. So you have negative 12 and 12. These are not equal. So it is not at 1, not at 2, not continuous. So just you can write that the point of discontinuity is real number except 1 and 2. Next one is quite clear. It is x less than 0, x greater than 0. So you have two expressions for less than 0 and greater than 0. And when x is equal to 0, you already have c. So left hand limit, right hand limit you have to find out, and you have to equate it with f0. f0 is what? C. So you will get a and b and c, but you will see that you will not get a value of b. You will just see. A and c you will get. For getting b, you have to apply a different tactic. So at 0, left hand side you have to write 0 minus h. For x, at above 0 you have to write 0 plus h, right? So negative h and h you have to use. So x less than 0, we have to put negative h here, because you are going on the left hand side of 0. Sign a plus 1 into, in place of h, just replace it by negative h. Plus, because 0 minus h is minus h only. Sign minus h. And divided by x is, this is minus h. Okay. So this sine negative theta is minus sine theta. Sine minus theta is minus sine theta. This is going to be minus sine a plus 1 into h. And then you have negative sine h divided by negative h. Now you can take negative outside from here. Sine a plus 1h will be there. And plus sine h. And you have a negative h in the denominator. So minus you can get cancelled, and h I am taking in the denominator and separating in this step only. Now apply limit h tends to 0. So you know that sine theta by theta limit theta tends to 0 is 1. So you can have a plus 1 in the denominator, a plus 1 in the numerator. I am just introducing it. As I said earlier, sine theta by theta is equal to 1. Now this whole will be 1, a plus 1 will remain. Here sin h by h, it is going to be 1, so 1 will remain, so a plus 2 you will get for the left hand limit. Coming to the right hand limit. Now for the right hand limit, it will be, see here, I am just changing the color so that you understand we are doing it for x greater than 0. So for x you have to put 0 plus h. So it is h, 0 plus h is h only, so replace this x by h. H plus bh square minus under root h divided by bh under root h. Now just take the under root h common. So you can write this root h in this root h. So what I am trying to suggest here is root h. You can take h common inside first. H 1 plus bh whole square. When you take h common, it will be only 1 plus bh. Now this can be written as under root h into under root 1 plus bh. So this root h and root h I am taking common. Why I am taking common? Common because root h is in the denominator. So root h we have taken common. 1 under root 1 plus bh minus 1 will be remain. And in the denominator you have bh into root h. So you can just cancel this root h and root h out. Now this we have to rationalize. So a minus b is there, so a plus b you have to multiply. So in this case, you have to multiply it by under root 1 plus bh plus 1. Here also under root 1 plus bh plus 1. So this is a plus b, this is a minus b. So a square minus b square it will be 1 plus bh minus 1. And in the denominator we have under root 1 plus bh plus 1. So we have bh already is here, bh, and then we have under root 1 plus bh plus 1. So this gets cancelled, bh because 1 minus 1 is 0, bh gets cancelled. You are in the denominator under root 1 plus bh plus 1. So limit h tends to 0. We have 1 by under root. So this is going to be 0. Under root 1 is 1. So 1 plus 1. So 1 by 2 you get. Okay. Now a plus 2 is equal to half. From left hand limit you got a plus 2. Right hand limit you got 1 by 2. So a plus 2 is equal to 2. A is equal to half minus 2. So 1 minus 4 by 2, that is going to be minus 3 by 2. So what do you get? A is minus 3 by 2. You see in the options, all the first 3 options have minus 3 by 2. So you have to think about C now. C is half. So first and third option becomes quite clear. The answer has to be equal to 1 and third. C is half, C is half, and A is negative 3 by 2. So what about B now? What to do with B? So we cannot directly get the value of B here. So for that, you have to see what is the scenario for this expression when you are talking about any expression which has B. So we have under root 1 plus bx minus 1 by bx. So we have to come here again. Okay. So this first and third we are checking which one is correct. This is x plus bx square minus under root x and divided by bx under root x. So under root x into, we have already done with h. I am just repeating it again. So 1 plus bx, it will be 1 plus under root bx minus 1, bx cancel, under root x will be there. So 1 plus bx minus 1 divided by bx. Now when this will exist, when the denominator cannot be 0, bx should not be equal to 0. When it should not be 0, we are not talking about x, we are talking about b. B cannot be equal to 0. So that this expression will be only valid when b is not equal to 0. So b is not equal to 0, that is b belongs to all the real number except 0. You can have all the value in the world except 0. So this is b. A is minus 3 by 2, b is real number minus 0, and c is 1 by 2. So third option is correct. This is your answer. If fx is this, so the point given is pi by 2 and it is being told that this function is continuous at x equals pi by 2, that is 90 degree. So if you assume the first function to be a, on the left pi by 2 will take a, take the second function as b, we have to take the right, on the right hand side, the b function. And this is continuous at x equals pi by 2. So which one of this is the correct option? So we just have to find out the left hand limit and the right hand limit, and we need to equate, and the relationship will be in front of you. Okay. So point of contention checking continuity is pi by 2. So left hand limit and right hand limit we are going to take. The left hand limit will take x as pi by 2 minus h. Right hand limit we are going to take x as pi by 2 plus h. So this is pi by 2 minus h. So this is m into pi by 2 minus h plus 1. This is what we have taken the first one. But on the right hand side we'll have to take the function b, which is sine. I am replacing this by pi by 2 plus h, sine pi by 2 plus h, and plus n. Okay. Now this sine 90 plus theta, you have to understand that it will be cos theta and positive cos theta, cos h it will be. First we'll solve this, m into pi by 2 minus mh plus 1. Just apply the limit and make the h term, whichever term is there, it is 0. So see, assume this h is very small. So we can just eliminate it. M pi by 2 plus 1, this will come on the left hand limit. Right hand limit, it is sine 90 plus theta. If you just go through this add sugar to coffee, that is where the different trigonometric terms, they are positive and negative. That is how we see here. So sine is positive here, sine 90 plus theta is cos theta, cos h it will be. So final is cos h plus n. So this is n. So cos h plus n, now apply the limit here also, and when h is 0, what do you get? Cos 0 is 1. So h tends to 0. Cos 0 is 1. This is 1 plus n. So left hand limit and right hand limit we are going to equate. X is pi by 2. So let us equate it. M pi by 2 plus 1 is equal to 1 plus n. 1 gets cancelled. M pi by 2 is equal to n. And what do you get? You get m pi by 2 equals n, and this is the correct option. the value of f0 so that the function this one becomes continuous for all x. This is given by, now f0 we have to find out. How f0 we are getting? Because we have to take the limit of fx at x tends to a is 0 here. So f0 basically we have to find out. So it is limit only. So this question will contain a lot of rationalization, and writing this again and again will be will take some time. So let me just brief you again. Limit x tends to 0 or x tends to a is 0 in this case. Fx is equal to f0. This f0 we are going to find out. So as I was suggesting, that this question has a lot of the terms which involves rationalization. So to rationalize, let us write them in a smaller version, and then we'll take them in deeper sense. What I'm trying to suggest here is I'm taking it as T1 and T2, just to let you know. The below one, or the denominator, I'm taking P1 and P2. Just we don't want to write that much. So here, just in order to understand, please assume that we have to first rationalize the numerator, or you can start with the denominator. I am rationalizing the numerator. So you have to just multiply it by the plus sign. Same term with plus sign. What you will get? A minus b and a plus b is a squared minus b squared. So root 2 t1 square minus root t2 square. So you will get t1 minus t2. So here you are going to get a square minus ax plus x square, and minus this bracket minus a square plus ax plus x square. Now just subtract a square minus ax plus x square minus a minus ax minus x square. So you just cancel these terms. This also you get minus 2x. So the numerator has been rationalized and you get the result as minus 2x. So what is remaining here is under root p1 minus under root p2. I have assumed p1 as a plus x and p2 as a minus x. So root t1 plus root t2 will remain, and I am going to rationalize this denominator. So let us rationalize it first. So same thing, when it is a negative sign, you just multiply it with the positive sign. So root p1 plus p2, and here also root p1 plus p2, just multiply this. And in the denominator you have root p1 minus root p2. Okay. So a minus b, a plus b, same thing we are going to do here. So you will get under root square, that is, you will get the p1 and p2 term, which we assume to be a plus x and a minus x. So p1 minus p2 is a plus x minus a minus x. So let us write it here, a plus x minus a minus x. So this will be a plus x minus a plus x. Get this cancelled. X plus x is 2x. So you get minus 2ax divided by 2x, and this you have got from the rationalization. But the plus sign still remain root p1 plus root p2, and in the denominator root t1 plus root t2. Okay, this is t1 t2, just to make you sure that this is p1 plus p1 and p2. Okay, let us now cancel these two. Minus 2x and minus 2x you can cancel, and only, no, there is just negative. So only minus a will remain. The result will be only negative a. You can just cancel these two out. Here you can apply the limit now. So f0, that is, in the place of x, just put 0. In place of x, put 0. So a plus 0 is under root a. Let us do with the this denominator I am doing root a minus plus root a, because it is under root t1 p1 plus p2. Please remember, numerator I am taking, numerator is under root p1 plus p2. Now coming to the t1 t2. T1 t2 is the numerator. Denominator is becoming numerator. Numerator is becoming denominator with a plus sign. So what do you get? Under root a square. Here also you get under root a square. Excuse me. So we have a plus a, and the numerator, what do you get? Minus a. This is twice of root a, and denominator you have 2a, Now you can just cancel 2a and only minus root a will remain. What will remain? Minus root a. So this is your f0. So the main key idea of this question is to rationalize and find out the limit. Most of the question, the result is minus under root this value which is coming by the limit. So what is minus root a? So minus root a is not there. So see, root x is simply x raised to the power, or a under root a is a to the power half. So it is negative. So this will not be the answer. The third one will be the answer. C is the answer. Now question number 17 it is. Now since modulus is not in the value of the function but in the boundaries of the function or the domain, or you can say on the limitation of the various boundaries or aspects. So I'll just take this question later in the end because this needs some effort. So I'll tell you about this question later. Let us finish all these first. Now this question and the next question, few questions are exactly like this. So you have to apply the same technique or logic in the other questions as well, right? So let us see it. This is f0 we have to find out. So what we have been doing, same thing we have to do. We just have to find out the limit of this function. And limit of this function, essentially it is f0 only, because limit x tends to 0, x tends to a, it is a is 0, fx is equal to f0. So you have to find out the limit essentially. And you need to have a fair idea about the roots, cube roots, nth root, how are you going to write it. And one more factor, one more important aspect of solving this type of question is this particular question is a raised n minus b raised n divided by a minus b. When you take the limit of this, what are you going to get, right? When you have this a form of this, and when the limit is, when limit x tends to infinity, it becomes different. We are talking about x tends to 0 here. So 27, you're taking the numerator first, 27 minus 2x raised to the power 1 by 3. And both n should be same. So we need something of power 1 by 3. So what is 27 cube root? Cube root of 27 is 3. So in place of 3, we can replace it by 27 raised to the power 1 by 3. Raised to the power 1 by 3 is simply cube root. Now coming to the denominator. Denominator, same thing we are going to do. Okay. So a minus b we have to do. Now since numerator we are taking, we have to introduce a minus b also. 27 minus 2x, just write this a minus b, that is 27 minus 2x and minus 27. So this we have introduced by ourselves. So what, this is a, this is b. So if the above is a and b, we have introduced by ourselves. So what is remaining here? If you cancel this 27 out, which we have by ourselves introduced, so minus 2x is extra. So since you have introduced the denominator, you have to put this minus 2x in the numerator also in order to cancel it, or make it the way it was earlier. Minus 2x we have introduced, right? Now this relationship, what is this final we are going to take? I'll just show you. This minus 2x is the extra. I'll just tell you what to do with this term what we have made. The solution of the numerator, when you apply the limit x tends to 0 in this, is going to be this 27 and raised to the power 1 by 3 minus 1. See, 1 by 3, the power will come in front, and then you take 27, which is b, raised to the power 1 by 3 minus 1. So 1 by 3 comes in the front, 27 you take here, raised to the power minus 2 by 3. How did this has come? 1 by 3 minus 1. So the power n minus 1, n comes front. So n, 27 to the power n minus 1. I hope you got the idea. Minus 2x was already there. So the numerator final we have done. Now coming to the denominator now. Denominator, same thing we are going to do. 9 minus 3 and 243 plus 5x raised to the power 1 by 5. Now this 3 is creating some kind of you can say bottleneck. So you can just take these 3 out. When you take 3 out, you have to take 3 common, so that we can get a proper form which we want, as we just did in the previous numerator. So we are dealing with the denominator, and since we have 1 by 5 as the power, and we need this something of the sort a raised n minus b raised n. So I am taking 3 common here. We have 3 inside, 3 has already been taken. So only 243 plus 5x raised to the power 1 by 5. Now we have b raised power n. Now this also we have to make something. So what is the number whose fifth root is going to be 3? So simply you can say x raised 1 by 5 is 3. So you can raise the power by 5. 5 gets cancelled in the left side. So it is 3 to the power 5. And 3 to the power 5 is simply 243. Okay, it's 81 into 3 basically. So you have 2243 raised to the power 1 by 5. 3 is already there. Please remember. I'll just mark it so that you know what we are going to use later, because these terms we just forget and we don't get to the proper answer. We have this 243, and this 243 raised to the power 1 by 5 it is. 245 raised to the power 1 by 5 minus 243 plus 5x raised to the power 1 by 5. So we are getting to this a raised n minus b raised n. But 243, see, we have to just change the position, because a raised n is not following the proper way we have to do. So I am taking the 243 plus 5x term first, and then 243 term later. And since we have done this, we have to take the negative outside. So we have minus 3 outside. And we have to have in the denominator 243 plus 5x minus 243. But when you solve it, you will get a 5x extra. This 5x extra has to be put in the numerator of the denominator, because we are dealing only with the denominator. So 1 by 5, what is the solution? 1 by 3. Now 243 to the power 1 by 5 minus 1. 1 by 5 minus 1 is what? Minus 4 by 5. Here minus 4 by 5. This is the denominator. And you have a 5x also. You have a 5x which we have introduced. So let me tell you what all we have done. There are certain things which are there. So the numerator is 1 by 3, 27 to the power minus 2 by 3 into minus 2x. Denominator is 1 by 5, 243 to the power minus 4 by 5 into 5x. So I'm just writing them, and I'll just clean all this and try to make them more clearer to you. But I hope you got the idea what we got in the numerator, what we got in the denominator. I'm just writing it for the sake of understanding that this is numerator, this is denominator, right? So let me do it again. Let me just write this, what all we have got. Minus 2x was there in the numerator, minus 5x was there, 5x was there in the denominator. Minus 1 by 3 was there. Remember, minus 1 by 3 was there, and we have the 2 by 15. You will get 2 in this minus plus 2 by 5 is a 15. So 2 by 15 you got. What about the numerator denominator value? 1 by 3 was there already, and this is 27 to the power minus 2 by 3, and in the denominator you have 1 by 5 and 243 to the power minus 4 by 5, and this minus 4 by 5. So this is 1 by 5, 1 by 3, 1 by 5, 5 goes up, 3 goes down, and this 243 to the power minus 4 by 5 and 27 to the power minus 2 by 3 can be taken up and down, because 1 by x raised to the power minus 1 is numerator x to the power 1. So I'm removing the negative sign. Now you got 4 by 5. What is 243? 3 to the power 5. 5 gets cancelled, you get 3 to the power 4. And this 27 to the power 2 by 3, 27 is 3 cube, sorry. So 3 cube, this 3 gets cancelled, and 3 cube it is. So this 3 cube gets cancelled, you have a 3 square only remaining. So you have 3 raised power 4 divided by 3 raised power 2. That is 3 into 3 into 3 into 3, and denominator you have 3 into 3. So 2 3 cancels, you will get a 9 in the numerator for this. Rest constant is already there, 2 by 15, 5 by 3, all is there. But you get here 3 by 4, 3 raised 4, and you have 3 raised 2. So this gets cancelled, 3 square it is. Now you just take all of them, 2 into 5 into 3 divided by 15 into 3. So just cancel these out, everything gets cancelled, only 2 will remain. So the final answer is 2 here. The answer is 2. Okay. Now this question, this kind of question we have already done. So it will be basically a raised power n minus b raised power n by a minus b, limit n tends to infinity. That is what we have to do, limit x tends to infinity. Sorry. Now this is a limit x tends to a. For example, we are talking about the continuity. So x tends to a is 0 here. Fx is equal to f0. Now this f0, we have to find out essentially the limit of fx at 0. What is the numerator? The numerator is 2 minus 256 minus 7x raised to the power 1 by 8. So this is numerator we are taking first, denominator we will take later. So what is the value? So that we take the 1/8 root, or you can say the 8th root, 1/8 power or 8th root. That will be 2. So this is how we get what we have to put in place of 2. So basically you have to raise to the power 8 both sides. So x equals 2 raised 8. So 2 raised 8. So you can do it like this. 2 raised 8 to the power 1 by 8 is actually 2. So 2 raised 8 is nothing but 256. So 256 to the power 1 by 8 minus 256 minus 7x to the power 1 by 8. Now this is, we can change the place of these two terms. Just to make it equivalent to the formula we will be applying here. So I am taking the terms, swapping the terms. Since we have swapped, we have a negative sign outside. What will be in the denominator? So this 256 minus 7x minus 256, you can just write like that. What will you get? This 256 gets cancelled, and minus 7x in the denominator we have introduced. Since we have introduced this in the denominator, we have to cancel this in the numerator also. Right? We have introduced this by ourselves. So we have to get rid of that. For that we have to apply it by negative 7x. Remember, negative was already there because we swapped these two items. So minus minus becomes plus, 7x will be there. This 7x. Now we'll apply the limit. Please remember, limit is not n to the infinity. Limit is x tends to the infinity. So this kind of questions, the answer or the result of this, a raised n minus b raised n. And here we have the limit x tends to 0. Because ultimately it will be 0 by 0 if you put x as 0. So 1 by 8 will come in front. 256 raised to the power 1 by 8 minus 1. So 1 by 8 minus 1 is negative 1 by 7. So 1 minus 8 by 8, this is going to be negative 7 by 8. 7x is already there, 7x already there. So this is the numerator we have got. Coming to the denominator now. Let me change the color so that you know that we are dealing with the denominator right now. We have 5x plus 32 raised to the power 1 by 5 minus 2 here. So 32 to the power 1 by 5 is 2. So here you can directly write 32 raised to the power 1 by 5. Denominator 5x plus 32 minus 32. So this is 32. We have introduced this by ourselves. So the numerator will be 5x. Because ultimately we have to cancel these two. So what is the solution? 1 by 5. 32 to the power 1 by 5 minus 1, which is going to be negative 4 by 5. So negative 4 by 5 it is. And we already have a 5x here. Okay. Now we have got the numerator, we have got the denominator. And I am taking this denominator and placing it below the numerator, the result of what we have got. So it will be 1 by 5, 32 to the power minus 4 by 5, 5x. So if x gets cancelled, 7 by 5 it is. Now 1 by 8, 1 by 5 is essentially equal to 5 by 8. 1 by 8 by 1 by 5 is 5 by 8. Okay. Now this minus, I am just taking the above in the denominator, the below in the numerator, because x raised minus 1 is 1 by x. You can say 1 by x raised minus 1 is x. So this becomes 32 raised to the power 4 by 5, and in the denominator I am bringing 256 raised to the power 7 by 8. So 32 to the power 1 by 5 to the power 4 you can do. Denominator also 256 to the power 1 by 8 to the power 7 you can do. And we have already seen that 32 raised to the power 1 by 5 is 2 only. It is 2. And 2 to the power 4 it will be. And what is 256 to the power 1 by 8? Again it will be 2. So it will be 2 raised to the power 7, because 7 is already there. The power of 7 is already there. So 2 raised to the power 7 you can write. So when you cancel these out, it will be 2 raised to the power 3 in the denominator. So 2 raised power 3 in the denominator. Just write it here. 1 by 8 it is. Now write it here, 1 by 8. So 5 gets cancelled, 7. Denominator is 8 8s are 64. 7 by 64 is your answer. Next one is we have a function which is continuous in the interval -1 to 1. It is continuous, it is already given in the question. So we have a number line here. Just to explain you that this -1 and 1, this is the interval, and -1 and 1 are inclusive because they are in the square bracket. If you have a round bracket, that means these two values will not be counted, or they are not included. But here it is included. Now -1 to the 1, that is what we have to see here. Okay. So -1 to 0, you have to take the first function which is I am indicating by A, and 0 to 1 you have to take this function which I am indicating by B. Why? Because we have to take the left hand limit and right hand limit, and we just have to equate. That is the whole point of the question or the answer. 0 is the point of continuity or discontinuity, which is given that it is continuous in the interval -1 to 1. Okay. So left hand limit and right hand limit will take and will equate it. So on the left hand side we have to put what? X equals 0 minus h. Right hand limit we have to put x as 0 plus h. This is left hand limit. X we have to replace by 0 minus h, which is essentially equal to minus h. Right hand limit 0x is equal to 0 plus h, which is equal to h only. So the first one we have to put it in A, second one we have to put it in the second one, which is B. So first minus h for left hand limit, right hand limit positive h. Let us place it under root 1 plus px. So minus h we replace, so it will be 1 minus ph minus under root minus 1 minus minus is plus. So because we are replacing negative h, so under root 1 plus ph it will be, and in the place of x negative h. We can do one thing. We can swap the position of the under roots, and we can get rid of this negative in the denominator. Okay. So let us try to do that. So we have 1 plus ph minus under root 1 minus ph. This is just been done to remove the negative in the denominator, right? Okay. So we'll deal with this h later. We just have to rationalize this. This we have to rationalize. Okay. So under root 1 plus ph plus under root 1 minus ph, this we have to multiply in the numerator and denominator. Okay. So let us a minus b, a plus b it is. So a square minus b square, it will be 1 plus ph minus 1 minus ph, and denominator we have under root 1 plus ph plus under root 1 minus ph. So numerator, because it was a square minus b square, so 1 plus ph minus 1 minus ph, so negative 1 cancel out, and we get a twice of pH. Please remember, it is not 2 pH, it is 2 pH. I'll just change it. So denominator, you remember H was already there in the denominator, so H gets cancelled. And applying the limit here, under root 1 plus under root 1 in the denominator is 2. Okay. So now this 2 pH divided by 2H it was. So finally what we get? We get only P. Please remember, we just get only P. So this is P on the left hand side, that is the -1 to 0. What we got? We got only P. Now we have to deal with the right hand side. So right hand limit, we just have to put 0 plus H, that is H. We just have to put this H. So 2 into H plus 1 divided by H minus 2. Now you can just apply the limit directly. Why? Because it doesn't matter. It will not be 0 by 0 or any other form. It will be just simply minus 1 by 2. So you can just equate these two. Just equate these two. What do you get? It will be minus 1 by 2. P is minus 1 by 2 is the answer. Minus half it will be. Now this is a question where we have 1 and root 2 we have to see. 1 and root 2. Okay. So let us see, because it is changing at 1 and root 2. Since the values are given from 0 to 1, 1 to root 2, root 2 to infinity. 0 to 1, 1 to root 2 and root 2 to infinity. So this is 1. This is root 2. Root 2 is basically 1.414. It is 0. It is infinity. From 0 to infinity, we have 1 and root 2 in between. And this function, whole function is continuous for x which is belonging to 0 to infinity. And then the most suitable values of a and b are. So we have to find out the left hand limit, right hand limit for 1, left hand LHL, RHL for root 2. We will equate and we will get the values of a and b. Okay. So let us start with the x equals 1 first. Then we'll talk about x equals root 2. So left hand limit, right hand limit for 1 we have to find out first. Please remember, left hand limit for 1 will be x will replace by 1 minus h. Right hand limit, it will be x equals 1 plus h. So we have 0 to 1 it will be x square by a, 1 to root 2 it will be a, and root 2 to infinity it will be 2b square minus 4b by x square. So we have to put this 1 minus h in x square by a. 1 plus h doesn't matter because it is a constant. A is a constant. And now equate this. 1 minus h whole square by a equals a. So this is 1 minus h whole square equals a square. And just put h as 0. So a square will be 1. A will be plus minus 1. You can apply the limit. You can open 1 minus h whole square. This is the way you have to show your examiner. Don't apply h directly here. A limit h tends to 0. Just 1 minus h whole square. You have to open this and then see what it comes. So finally, as I was discussing, it is a square equals 1. A is plus minus 1. So we are getting two values of a. Now coming to root 2. Now this root 2, if you see here, the left hand side or left hand limit will be only a, because 1 to root 2 is a. And from root 2 to infinity, it will be 2b square minus 4b by x square. And we have to put x as root 2 minus h. And right hand limit, we have to put root 2 plus h. So left hand limit, right hand limit. So it is a. Left hand limit, you don't have to do anything. It is because it is already a. It is a constant. So where are you going to put root 2 minus h? Nowhere. On right hand side, it is 2b square minus 4b. This is also a constant. But in the denominator, you have to put root 2 plus h whole square. Either you can root 2 plus h whole square. Let me just open this. Root 2 plus h whole square is 2 plus h square plus root 2h. A square plus b square plus 2ab. It will be 2 root 2h. So h means wherever h is, just remove it. Only 2 will come. So 2b square minus 4b by 2 is equal to a. Now you can just take 2 common and cancel these out. B square minus 2b is equal to A. Now B square minus 2b equals A. A has 2 solutions. Remember? A was plus 1, A was minus 1. When you take A as 1, it will be B square minus 2b equals A, and when it forms a quadratic equation, it will be B square minus 2b minus 1. When A is minus 1, B square minus 2b will be equal to negative A. So when it comes on the left hand side, it will be plus 1. So this one is simply B minus 1 whole square. So what do you get? B equals 1 you get. See, B minus 1 equals 0, B equals 1. So when A is equal to minus 1, B is equal to 1, this is one solution. Now coming to A equals 1, you have to solve this equation, and that will not be solved by the factorization. You have to solve it using the Sridhar formula. So B equals minus B plus minus under root B square minus 4AC by 2A, that you have to do. So just equate it with AX square plus BX plus C. So minus minus plus minus 2 plus minus under root B square minus 4AC. So 4 minus 4 into minus 1 divided by 2. So you get 2 plus minus, this is 4 minus 1 minus 4. This is going to be 8. So you can just write it as 2 root 2. Under root of 8 is 2 root 2. And divide by 2. You can take 2 common, cancel it. This out, 1 plus minus root 2. So for a single one solution, you are getting 2 solutions. So this is not acceptable. For A1, you are getting B as 1 plus root 2. You are getting 1 as 1 minus root 2. That is not acceptable. So A is equal to minus 1. B is equal to 1. This is your answer. This is your answer. So this type of question, as you remember, we have already done this question in our the question answers also, exercises also, and also in the VSAQ, very short answer question. Remember, since f equals f pi by 2 equals lambda, this is given in the question. X is not equal to pi by 2 because x minus 2 by whole square will be 0. So the fx will be continuous function at x equals pi by 2, where lambda is what? So you have to find out what is f pi by 2, because that will be equal to lambda, right? So things what we are going to do here is limit x tends to pi by 2, and this is fx equals f pi by 2. This is what you have to do, right? So this limit you have to find out. 1 minus sin x, and the limit at the pi by 2. Limit at pi by 2. This is what you have to find out. So 1 minus sin x by pi minus 2x whole square. So x is tending to pi by 2. Since the question is saying it is already continuous at x equals pi by 2, so the left hand limit and right hand limit will be equal. So either you put x as pi by 2 minus h or x as pi by 2 plus h. It is up to you. Why I am saying this? Because the left hand limit and right hand limit we have been doing till now, they are already equal. So x equals pi by 2 minus h. You can also put pi by 2 plus h. This is up to you. So limit h tends to 0. X you have to put as pi by 2 minus h. So 1 minus sine pi by 2 minus h divided by, so pi minus 2 into pi by 2 minus h. I am not squaring, just solving this. Pi minus 2 gets cancelled. Pi minus pi plus h plus 2h, sorry. So pi gets cancelled. You have 2h, and there was a square also. Pi minus 2x pi minus 2x whole square. So this is 2h whole square is 4h whole square. Now you have 4h whole square. What about the numerator? Sin 90 minus theta is cos theta. So 1 minus sin pi by 2 minus h. So 1 minus sin pi by 2 minus h is cos h. So 1 minus cos h is what? 2 sin square h by 2. Now you have 4h square already. So the sin theta by theta limit, sin theta by theta limit theta tends to 0 is 1. So sin h by 2 whole square it is. You need h by 2 whole square in the denominator also. Already h square is there. So you have to have a 4 here. And you have to, when you introduce a 4, you have to have a 4 extra also in the numerator so that it cancels out. What I am trying to do here is limit sin theta by theta equals 1, that we have to do. So this whole is going to be 1 when you apply the limit. Sine theta by theta, as I just told you, limit theta equals 0 is 1. So what do you get? 2 by 16, so it is going to be 1 by 8. So f pi by 2, which is essentially equal to lambda. Lambda we have to find out, which is equal to 1 by 8. 1 by 8 is the answer. Now here, the value of a for which the function fx is equal to, so we are being provided two different functions for x not equal to 0, x equals to 0, and this may be continuous at x equals 0. So what you have to do is, when it is not equal to 0, that is if you want to find out the limit, you have to use this, and we have to equate it with the value at x equals 0. Okay. So the whole exercise is all about limits. So if you are able to do the limits, then it will be easy. So limit x tends to 0, fx equals f0. Basically we have to find f0. So for that, consequently, we have to find out the limit of this function. And then we'll equate it to 12 log 4 to the power 3. So I'm taking the numerator first, 4x minus 1 raised to the power 3, that is cube. Now you know that a raised x minus 1 by x, if you take the limit of x tending to 0, what do you get? You get log a. Please remember, the base is e. Log, it is basically ln. So it is a raised to the power x minus 1 by, so you need this x, and already you have this x cube. So if you introduce this x cube, you have to have a x cube in the numerator also. So 4x minus x minus 1 by x whole cube, limit x tends to 0, it is x cube we have introduced ourselves. So what is the answer here? If you take the limit, it is log 4, the base is e, to the power 3. Now coming to the denominator. So we have sine x by a log 1 plus x cube, x square it is. So I'll just change it. You'll see there will be some problem coming. So I'll just change it. It is x square by 3. So log 1 plus x by x, what is this? It is going to be 1 when limit x tending to 0. So limit x tends to 0 for sine theta by theta or sine x by x, this is going to be 1. So we need a x by a in the denominator. So we have to have a x by a in the numerator. So what do you need in the denominator here? You need to have, because this is log 1 plus x square by 3, so you need x square by 3 in the denominator, so you will have x square by 3 in the numerator also. Please see that I am writing x cube, but it is x square actually. You will just see what will happen. So this is going to be 1 sine theta by theta, limit x tends to 0. This is going to be 1 sine log 1 plus x square by 2 divided by x square by 3 divided by x square by 3. This is going to be 1. So what is remaining here? The numerator and denominator we are going to write. So x cube log 4 to the power 3 divided by x into x square and 3a. It is not x cube, it is x square actually. So x cube whole will get cancelled. So it will be only log 4 cube divided by 3a, and that will equate to 12 log 4 to the power 3. Okay. As I was saying, it is not x cube by 3, it is x square by 3. So let me just change it and then we can equate it. So essentially the whole idea is to find out the limit of the first function, and we will equate it to 12 log 4 to the power 3. So this is log 4 to the power 3, and since 3a was in the denominator, it goes 1 by denominator, so it goes up. And this log 4 to the power 3 is going to get cancelled from the right hand side also, because we are going to equate it with log 4 to the power 3 into 12. So this gets cancelled, 3, so a is going to be 4. So this x is extra, because as I told you, this was my mistake, so I accept that. and I'm going to change it. I'm just going to amend it. So the whole idea you understood how to find out a equals 4. Simply take the limit of the first function and equate it to the 12 log 4 cube. So I'm just changing it. It gets cancelled. X cube gets cancelled. This x which I just wrote was non-essential. It was not there already because it was x square by 3 actually. So a is equal to 4. The function fx is equal to tan x is discontinuous on the set. Now tan x is simply sin x by cos x. But you need to know about tan x also. What is the graph of tan x? Where it is, you can say where it is valid, where it is not valid. So tan 2n plus 1 pi by 2, if we take the third option, what do you get? Tan into 2n into pi by 2 plus pi by 2. This gets cancelled. You get pi by 2 plus n pi. So tan 90 minus theta, tan 90 plus theta is cot theta. Add sugar to coffee. If you see here, the pi by 2 plus theta is only positive for sine. So it will be a negative. And always 90 plus theta or 90 minus theta, the tan will change to cot, sine will change to cos, like that. So it will be cot n pi and negative of this. It is in the second quadrant. Now cot n pi, if you understand it very closely, it is simply cos n pi by sin n pi. But we know that cos of, we are interested in the denominator. So we will not be talking about cos n pi. Sin n pi, sin 0 is 0, sin 180, sin 360 is 0, n pi, that is 2 pi is 360 degree. So when you have the 0 in the denominator, because it is essentially coming, 0 is coming here. Sin pi, sin 2 pi, sin 180 degree, sin 0 degree, sin 360 degree, 0 and 360 degree, they are 0. So you have in the denominator 0, but you cannot afford it because this is indescribable, right? So this is undefined. That is why this third option is the correct option for the discontinuity on the set where fx is equal to tan x and 2n plus 1 pi by 2 where n belongs to z, because we have already seen this is not defined at the integral points 1, 2, 3, etc. The function fx is equal to sin 3x by x and k by 2. It is sin 3x by x when it is not equal to 0, otherwise it is k by 2. So this is continuous at x equals to 0, so you just have to take limit x tends to a, which is x tends to 0 here, and sin 3x by this is x is simply fx, and this is equal to f0. What is fa? f0. So we'll just find out the limit of sin 3x by x and we'll equate it to k by 2. So sin 3x by x it is, so introduce 3 in the denominator, in the numerator also. And you have sin theta by theta, limit theta tends to 0, it is always equal to 1. So we have introduced this 3 in the denominator, so we have to have a 3 in the numerator. Sin theta by theta is 1, only 3 will remain. And what it is equal to? It is equal to k by 2, which is essentially equal to f0. So k by 2 is equal to 3, that is k is equal to 6. This is your answer. If the function fx is equal to 2x minus sin inverse x divided by 2x plus tan inverse x, this is continuous at each point of its domain, then the value of f0 is, this is continuous, so you just have to find out the limit and just equate it to f0, that is the value of the function at the point of discontinuity. So we have to find out limit. Again, the main crux of this exercise is finding out the limit. 2x minus sin inverse x divided by 2x plus tan inverse x. What you can do here is, you know that sin inverse by x and tan inverse by x, limit x tends to 0 is 1. So you can take a x common. It will be 2 minus sin inverse x by x. Then you can take x common here also. You will get 2 plus tan inverse x by x. As I said, You need to remember sin theta by theta, limit theta tends to 0, 1. Sin inverse x by x, limit theta x tends to 0 is 1. Similar for tan, because tan is simply sin by cos. So when you apply the limit, it is going to be 1. So replace this by 1, all these. So 2 minus 1 divided by 2 plus 1 it is. It is going to be 1 by 3, and that is f0. 1 by 3 is the answer. The value of b for which the function this. So you have the point of discontinuity or continuity as 1. So this is continuous at every point on its domain. It is given in the question. This is 0, this is 1, 2. So the point of contention is, or the continuity discontinuity is 1. And since it is given already that it is continuous, so we'll be taking the left hand limit and right hand limit in terms of 1 and equating it so that we can get b. So we need just one equation to solve this b. So left hand limit will take x as 1 minus h. On the right hand side, we are going to take right hand limit, we are going to take x as 1 plus h. So this is 5 into 1 minus h minus 4. On the right hand limit, it is 1 plus h. So 4 1 plus h whole square plus 3b into 1 plus h. We have to replace x by also 1 plus h. This is going to be, if you replace this h by 0, apply the limit here itself, it is going to be 5 minus 4, that is 1. Here you have 4 into 1 plus h square, that is 4 only. Then 3b into, again, if you apply limit here, 1 plus h, it will be 3b plus 3bh. 3bh will be 0 and 3b it will be. So 4 plus 3b is equal to 1. 3b is equal to 1 minus 4, that is minus 3. b is equal to negative 1. That is your answer. If fx is equal to 1 by 1 minus x, then the set of points discontinuity of the function f of fx. So there are 3 levels of fx. First fx, then f of fx, then f of fx. So let us start with fx first. 1 by 1 minus x. Now please remember, every time in mathematics, denominator cannot be 0. 1 by 0 is not defined. It cannot be defined, right? 0 in the denominator is not acceptable. So when are you going to get 0 in the denominator for this fx or this function? When 1 minus x is equal to 0, when it will be? When x is equal to 1. So first is 1, but you have 1 in all these 3. So you have to go for some other value also when we apply these 3 levels of fx. Now f of fx is what? Replace x by 1 minus x in this. So 1 by 1 minus x. Okay. So this becomes 1 by 1 minus x minus 1 by 1 minus x. So 1 minus x minus 1 divided by 1 minus x. This 1 minus x goes in the numerator, 1 minus x minus 1. So negative 1 and 1 gets cancelled. You are remained with minus x. Now I'll just change the position of x and 1 in the numerator so that you get x minus 1 divided by x, because negative sign is avoided, or we have got rid of that thing. X minus 1 by x. Now you cannot have a denominator again as 0, so x cannot be 0. So this is a point where you have a discontinuity. Please remember, again I am reiterating, 0 cannot be in the denominator. It's absolutely not acceptable. 0 and 1 is the answer. But we still haven't reached the third level. So whatever has come, you have to put it in 1 by 1 minus x. So you have to go one more level. This x minus 1 by x has to be replaced in the place of x of 1 by 1 minus x. So let us replace it. 1 by 1 minus x. So in place of x, put x minus 1 by x. Okay. So what do you get? You get 1 by x minus x plus 1. This x goes in the numerator. This x by x gets cancelled, 1. So this is x in the numerator, so it doesn't matter whatever it comes. But the 1 and 0 is a problem. So this second is the answer. fx equals to tan pi by x 4 minus x divided by cot 2x, And x should not be equal to pi by 4. You can check it. Cot 2 into pi by 4 is cot, this is 2 by 4, so cot 90, it will be pi by 2 actually. And this is not defined. This is not defined. So this is undefined, and when it is not undefined, you cannot, means it is 0. Because 10 pi by 2 is infinity, 1 by 10, 1 by infinity is 0. You cannot have a 0 in the denominator. That is why the question is itself saying x cannot be equal to pi by 4. So the value which should be assigned to fx at x equals pi by 4, so that it is continuous everywhere, is. So you don't have to do anything, you just have to find out the limit of this function. And since you have to equate it with f pi by 4, the function value at pi by 4. So let us see here. This is continuous everywhere. So the left hand limit and right hand limit you don't have to find out, because it is already continuous. Left hand limit and right hand limit has to be equal. So I am just saying you can either put pi by 4 minus h. You can either put pi by 4 plus h. It's up to you. Right? So let us find out the limit here. I am just taking pi by 4 minus h. You can always take pi by 4 plus h. It's up to you, because LHL and RHL are going to come same. So I am replacing pi by 4 minus h. H is tending to 0. So limit h tends to 0. 10 pi by 4 minus, now replace it by pi by 4 minus h. In place of x, pi by 4 minus h. Okay. So let us see what it comes in the denominator. Cot twice of pi by 4 minus h. So in the numerator you get pi by 4 minus pi by 4 plus h. So it is 10h only. Pi by 4 minus pi by 4 plus h, it gets cancelled. You have 10h, and divided by cot, you can just multiply this 2 with pi by 4 minus h. So 2 into pi by 4 minus 2h it will be. So this is pi by 2 minus h, and cot 90 minus theta is tan theta. Cot pi by 2 minus h, 2h it is. So tan 2h it will be. It is tan 2h. Now 10h by tan 2h. So tan theta by theta, limit theta tends to 0 is 1. You know about that. Tan sin theta by theta is also 1. So tan h by h I am introducing. So h will be extra. And tan 2h by 2h. So 2h will be extra. Now apply the limit in both of these, numerator and denominator. So tan h by h and tan 2h by 2h is going to be equal to 1. So only 1 by 2 will remain. H gets cancelled. So f pi by 4 is going to be half. 1 by 2. Now the function fx is equal to this, and this is not defined for x equals 2. You can see if you put x as 2 in the denominator, you'll get 2 minus 2, which is equal to 0, and that 0 in the denominator is not acceptable at all. So in order to make the function fx continuous at x equals 2, here f2 should be defined as, again the same concept, you have to find out the limit of this function at x equals 2. So f2 has to be found out, that is basically the limit. Now you have to find out the factorization. I am not going to tell you how to factorize it, because this is the basic thing. 6th, 7th, 8th, 9th, 10th, you have been doing this factorization now and again, always. So this factorization is important, and x minus 2 whole square into x plus 5z is the factorization. If you have any problem, just take the reference on the left hand side, which I put an arrow. So this is because you are in 12th, you need to know how to do this factorization. Okay, coming to the denominator, so x minus 2 whole square and x plus 5, x minus 2 in the denominator, you just cancel these 2 out, x minus 2 into x plus 5. Now just replace x by 2 here, because it is limit x tends to 2. What do you get? It's 0 into 7. But it doesn't matter 7 is there or not, because x minus 2, that is 2 minus 2 is 0 only. So you get a final 0, f2 is 0, right? So in order to make fx continuous at x equals 2, f2 should be defined as 0. So the main idea of this question is to find out what? Find out the factor. If you're not able to find out the factor, you will not be able to solve this question. Factorization is important. So everything is important, trigonometry, etc., etc. If fx is these two functions are given, and this is continuous at x equals 0, then A equals. Now here the point of contention or the continuity discontinuity is x equals 0. And if you go to left, the first function you are going to use. If you go to the right, the next function or the second function you are going to use. Okay. So we'll try to find out the LHL, RHL and try to find out the value of A. The first thing first is left hand limit. That is because x is 0, so we have to go on the left. So x will be 0 minus h. Right hand limit, we are going to take x as 0 plus h. So this A sine pi by 2, in place of x, replace it by negative h. So this is your explanation. If you want to do it by yourself, you can just have a look. Otherwise, you just follow me. So what do you get? It's minus h you have to put in place of x. So it is negative h plus 1. Negative h plus 1 can be written as 1 minus h. So I'm just writing 1 minus h here and multiplying pi by 2 with 1 minus h. We get pi by 2 minus pi by 2 h. So don't worry about pi by 2 minus h, just see pi by 2 minus something. So sine 90 minus theta is cos theta. It is A sine pi by 2 h. A cos sine 90 minus theta is cos theta. So you have this A cos pi by 2 h, right? So cos pi by 2 is, the h is 0, so cos 0 is 1. So A you get. On the right hand limit, you get 10x minus sin x by x cube. So 10h, I am replacing it by h, x by h, so 10h minus sin h divided by h cube it is. So this 10h can be written as sine by cos. Here you have sine. So numerator I am just taking. Sine I can take common. You get 1 minus cos divided by cos. That is 1 by cos minus 1 will be equivalent to 1 minus cos by cos. So sine into 1 minus cos by cos it is. Okay, sine by cos you can write it as tan. And 1 minus cos theta is 2 sine square theta by 2. So you can write 2 sine square. What is theta here? H. So 2 sine square h by 2. And you have this sine. And since we already have this cos in the denominator, so we have tan. Sine and cos is tan. So we have 2 sine square h by 2. What about the h cube in the denominator? It was already h cube. So we can utilize h square for sine square h by 2 and h below tan h. That is how we can utilize. But since it is sine square h by 2, you have to have h square by something. So h square by 4. So you have to multiply 4 here. Sine theta by theta limit theta tends to 0 is 1. And tan theta by theta limit theta tends to 0 is also 1. So both these you can just eliminate because they are just ones. So you have 2 and 4 remaining. 4 in the denominator, 2 in the numerator. So just cancel it out. It will be half. And you have to equate it with using the left hand limit. So A is equal to half. This is your answer. So if fx is continuous at x equals 0, A should be equal to 1 by 2. A option is the answer. First option is the answer. If fx are these three functions, one is a constant function which is 4, then the value of AB, for which AB is in pair, A comma B, for which fx cannot be continuous at x equals 1 is, please remember they are asking cannot be continuous. They are not asking can be continuous. So we have to select by rejecting. So these are the point. We have 0, 1 and 2 are the point. And since x equals 1 is the point given in 4, and we have to check for non-continuity at x equals 1. So we will go left, 1 minus h will go right, 1 plus h, left hand limit, right hand limit, x square plus b for the left hand limit, x square, the second function for the right hand limit, and 4 is the value of the function at that value which is 1. I hope you got the idea. Let us take the left hand limit now. This is left hand limit. We have to put x as 1 minus h because the point of contention is 1 minus h. Right hand limit is x equals 1 plus h. Now just put 1 minus h in x square plus b. You have to put 1 plus h in x, this second function. Okay. So 1 minus h whole square plus b. Here what are you going to write? 1 plus h plus 3 because it is x plus 3. So this is, you can just open it, and wherever h is there you can apply the limit and just remove those terms. So you have b plus 1 only. Okay. And this is a, please remember it is a into x square plus b. So we'll just include this a here. So a into 1, because we have to talk about a and b both. So a into 1, a into x square plus b it is. So a 1 minus h whole square plus b, you can just cancel h square minus 2h, a plus b it is. On right hand side it is going to be 4 directly. So a plus b is equal to 4. That is what LHL equal to RHL equal to the value of the function at x equals to 1, which is 4. For which values this cannot be continuous? So when you add a and b, it should come as 4. It will be okay. Otherwise, won't be okay. So 3 and 1 you add, it is 4. You add 4 and 0, it is going to be 4. You add 2 and 2, it is going to be 4. So all these are valid solutions. One of the solution 5, 2 is not valid because 5 plus 2 is actually equal to 7, which is not equal to 4. So 5 plus 2 is 7. 7 is not equal to 4. So 5 and 2 is that point of not continuity. That is the a and b pair for which f, k cannot be continuous at x equals 1. If the function fx is defined by fx is this, x not equal to 0, the first function, x equals to 0, the second function, which is k, constant function. So we'll take the left hand limit, right hand limit, and we'll try to equate. And since see, LHL, RHL is not required because it is already being said that it is continuous at x equals to 0. So just find out the limit of x tends to 0 for the first function and equate it to k. So first function is log 1 plus 3x minus log 1 minus 2x, and you have to have a x in the denominator. Here also we have x in the denominator. So what do we need? So all this log 1 plus x divided by x and limit x tends to 0, or you can just write log 1 plus theta by theta, theta tends to 0, both are same, is equal to 1. When limit of that term is x or theta is tending to 1. So 3x we have included, so 3 has to be going up. 1 minus 2x, minus 2 in the denominator, minus 2 in the numerator. So just apply the limit. Log 1 plus 3x by 3x is 1. Log 1 minus 2x by minus 2x is 1. 3 remain here. Minus minus is plus, so 3 plus 2 is 5. Just equate it to k, and that k is going to be 5 for the continuity at x equals to 0. If fx is like this, the point is x equals 0, go left, you take the first function. When you go right, you use the third function. So 0 minus h on the left hand limit to 0 plus h on the right hand limit, then the value of a so that the function f may be continuous at x equals 0 is. Okay, let us find it out. Okay. And the most important trick of this question is you don't have to go for LHL and RHL. You will get, because there is only one value a, one variable you need to find out. So one equation is enough. If it would have been a and b, you need at least two equations. So LHL, RHL, you didn't have to do RHL. Let us do it only on LHL, but you can do on RHL and equate it to the value of a. But I'm doing only on LHL. So x equals 0 minus h, that is minus h you have to put. So 1 minus cos 10 into minus h, cos minus theta is plus cos theta. So it will be only cos 10h divided by x square. X square minus h whole square is h square only. So 1 minus cos 10h divided by h square. 1 minus cos 10 theta is what? See, 1 minus cos theta is 2 sin square theta by 2 in every sense. So whatever theta is there, just divide it by 2. And 2 sin square, that is theta by 2. So 2 sin square 10h divided by 2 is 5h. So 2 sin square 5h it will be. And you have in the denominator, you have h square. So you have to have a 5 square in the denominator because it is 5 sin 5h whole square. You already have h square, include 5 square. So sin 5h whole square. So you need to have a 5 in the denominator. That's what I'm talking about. So phi h square is already there, phi square you have included, so phi square you have to go and put it in the numerator as well. So now just apply the limit here, sin theta by theta, limit theta tends to 0, so it is going to be 1. So what do you get? 2 into phi square. This is going to be 1, which is sin theta 5h by 5h. Okay, so you get this as 1 and 2 into phi square, so phi square is 25, for 25 into 2 is 50. And since it is equal to the value of the function at a, value of the function at 0, which is equal to a. So RHL you don't have to find out. If you want, you can find out the RHL and equate it to a. That is the way you can do. But I am comfortable with the left hand side. So I found the answer as a equal to 50. So the option is second. The option you need to choose is the option number 2. Okay. So this is how we are going to solve. We have been solving this type of question because we are on the 34th question. So all these questions are exactly like that. If fx is x sin x, x is not equal to 0, then the value of the function at x equals to 0, so that the function is continuous at x equals to 0 is. So you just have to find out the limit of x sin 1 by x. Limit x tends to 0 because x is not equal to 0. Fx is equal to f0. A is 0 here. F0. Okay. So let us see what we can get here. Now here is the next question is also giving you some certain thing I am going to explain there. But here we are not talking about sin 1 by x. We just need to talk about x tends to 0. Right? The whole idea of this exercise is finding out the limits. If you are comfortable with finding out the limits, this exercise will be very easy to you. Now when we apply the limit to x sin 1 by x, you just see limit x tends to 0 for x is 0. So whatever comes outside or with it in the multiplication, we don't worry about. Sin 1 by x, x is going to be 0 and 1 by 0 is infinite, sin infinite. So you can argue that sin and theta is always between -1 and 1. Whatever you put inside sin, it will be -1 and 1. But 1 by 0 is of course undescribable because sin infinity it is. But since 0 is multiplied by whatever it comes, 0 into infinity is also 0. So we can just say it is 0. The answer is 0. F0 is 0. You'll see what we are going to do in the next question. Now same discussion applies here. The value of k for which the function fx sin 1 by x for x not equal to 0, k for x equals to 0, continuous at x equal to 0 is. So we'll just find out the limit of sin 1 by x. We'll try to equate it with k. So sin 1 by x, limit of sin 1 by x is equal to k. But the problem here is that, as I told you, sin 1 by 0, anything in the denominator is not acceptable. Whether it is inside sin, whether it is outside sin, doesn't matter. So 0 into sin 1 by 0, the previous question we have just argued that 0 multiplied by anything is 0 only. So we'll go with 0. But here it is 1 by 0 in sin only. Sin infinity, you'll get an answer between -1 and 1. I'm not denying that. But inside 1 by 0 is not acceptable. So sin x tends to 0, sin 1 by x does not exist. Thus or consequently, there does not exist any k for fx that makes it as a continuous function. So none of these is the answer for this particular question, which was not in the previous question, remember. The values of the constant a, b, c for which the function fx is equal to this. So you have a constant for x equals to 0, b, and this may be continuous at x equals to 0. So there are point on the left of x equals 0. You have to take the first function. On the right, you have to take the last function. Okay. So A and B and C. So you need at least 3 equations in order to get 3 variable, 3 equation, 2 variable, 2 equation, 1 variable, 1 equation. That is how it goes. So this left hand limit and right hand limit we have to equate. And we have to equate it with the value of the function at 0, which is actually B here. Which is B here. So just equate like that. Okay. So left hand limit, let us start with the left hand limit. This has to be applied on 1 plus ax to the power 1 by x. And since it is 0, we have a left hand limit as 0 minus h. So we have to replace x by minus negative h basically. So those who wants to do by themselves, I'm just showing you the result, how you are going to write it. We'll talk about the first one and we'll go subsequently to the second part of the right hand limit. But left hand limit is, I'm replacing the x by negative h. So this is negative h, 1 minus ah, and to the power 1 by x, just replace it by negative h. So 1 minus ah to the power 1 by 1 minus h, or minus 1 by h. So this is equivalent to what? F0, which is b. Here it is b. So b is equal to 1 minus ah to the power 1 by minus 1 by h. So basically it is 1 minus ah, b equals 1 minus ah to the power minus 1 by h. Whenever you have a power like this, you just take log. It will be very easy. So when you take the log b, the power comes outside, minus 1 by h, and then you have log 1 minus ah. So log, and please remember this log is log base e. The base is e. So now you have to have a negative ah in the denominator. The negative ah we have to put in the numerator. Since already a negative h is there, because log 1 plus x by x is 1, limit x tends to 0. But we have a negative 1 by h in the numerator, in the front already, which has come in front because we have taken the log. So what you have to do is, this negative h was already there. This was already there, minus h. So you just have to introduce an a in the numerator and in the denominator. Log 1 plus h x by x, as I just told you, is going to be equal to 1. So when you apply the limit goes inside the log, and this is going to be simply 1. Log of this is going to be 1, and only a will remain. So log b equals a. So this is the first relation, e raised to the power a is b. This is the first relation. We are going to just keep it so that we go to the second part and then see what comes, and then we'll reuse this log b equals a whenever it is required, because we are intending to find out the value of a, b and c. Okay, so let us come to the second part of the right hand limit basically. This, just keep in mind, I'm just replacing all of it. We'll use it in a short while. Now x plus c to the power, this is x plus c to the power 1 by 3, and denominator you have x plus 1 to the power 1 by 2. So replace x by 0 plus h, that is h, in place of x wherever it is. So h plus c to the power 1 by 3 minus 1, and then you have h plus 1 to the power 1 by 2 minus 1. Now there is a typo error or whatever it is. See, always remember x raised to the power n minus a to the power n divided by x minus a. Limit x tends to a, this n comes in front, a to the power n minus 1. This is the result of the limit. So we will try to make these terms in numerator and denominator in such a way so that we get the limit x tends to a, and we can finally find out and replace it by a raised to the power n minus 1. In the denominator you say that this is h plus 1 or h plus c to the power 1 by 2. This is root only, and whenever there is a root you go for rationalization. Okay, so half power is root only. So h plus 1 to the power half plus 1, h plus 1 to the power half plus 1, we are multiplying numerator denominator in order to rationalize the denominator of this term. So h plus c to the power 1 by 3 minus 1, and this is going to be h plus 1 to the power half plus 1. Now this is going to be a square minus b square, so h plus 1 half to the square minus 1 square. 2 gets cancelled, h plus 1 minus 1, 1 gets cancelled, you get only h. You just have h. So you have h in the denominator. Now you can here only apply the limit on the term which we got in the numerator. H plus 1 to the power half plus 1. So this is going to be 1 plus h is 0, 1 plus 1 to the power half, that is 1 plus 1, that is 2. But we'll deal with it later. We are discussing the x raised n minus a raised n by x minus a. So you have h plus c minus 1. I am saying we have to have h plus c minus 1 in the denominator also. When we have h plus c minus 1 in the denominator, and since in the answers we see c equals 1, this is a point you have to understand really well. See, h was already there, h is already there. We have to include certain thing and subtract something so that it becomes h plus c minus 1. So apply the limit h tends to 0 on the right, which I was saying one root is 1 only, 1 plus 1 is 2. So 1 plus 1 is 2, this will be using later. But here h plus c to the power 1 by 3 minus 1 by 3. So in order to make it as x raised n minus a raised n by x minus a, we need x minus a in the denominator. So h plus c minus 1 we need. But since in the options of the answer c is equal to 1, see here. So we have a c equals 1 here. So if h plus c minus 1, so I am talking about c equals 1 here. So you can write the denominator as h plus 1 minus 1, or essentially it can be h plus c minus 1, just to make it similar to the numerator. C equals 1 is already the option, so we can always employ it. So C both are h plus c minus c. We are saying h plus c minus c because c gets cancelled, you get h. But here 1c I am writing c, 1c I am writing it as 1 because it is in the answer. So once you have h plus c minus 1 in the denominator, it follows the form or takes the form of this x raised n minus a raised n by x minus a. Okay? So this is going to be n a raised to the power n minus 1, 1 by 3, 1 to the power, that is c is basically here. 1 to the power 1 by 3 minus 1. 1 by 3 minus 1 is minus 2 by 3. Now 1 to the power anything is going to be 1 only. It doesn't matter. C is 1 we are taking here. In the answers options it is already given. So we can either use c as 1 or use c equals minus 1 and then try to solve it. But since c that is 1 to the power minus 2 by 3 or whatever it is, 1 to the power anything is 1 only. So this is basically 2 was on the right, 1 by 3 is there, and this is equal to what? 2 is already there. So this is equal to what? Left hand limit, right hand limit. Remember, I told you it is equal to b. The value of the function at x equal to 0. So b is equal to 2 by 3. So basically b is equal to 2 by 3. So from the right hand limit you got b as 2 by 3. And you remember a was equal to log b? The first left hand limit when I was showing you, we came up with the solution that a equals log b. So a is equal to log, replace b by 2 by 3, a equals log 2 by 3. We have taken c equals 1. So a and b is matching. A is log 2 by 3, b is 2 by 3. So this is the answer. Okay. The points of discontinuity of the function. So at what point we are going to discuss? If you see it on a number line, it's between 0 and 4. There are 3 functions. So the point 1 and point 5 by 2 is of our concern. Between 0 and 4, this 1 and this 5 by 2. So this 5 by 2 is simply 2.5, right? So there are 3 functions here. So you have to tell that the points of discontinuity of this function is where? At 1, at 5 by 2, at 0, at 4, where? Okay. Before actually solving it, it's quite easy because we just have to check for 1 and 5 by 2 because this is the point where the function is changing. So this 2 root x is simply a polynomial function. It's 2x raised 1 by 2. 1 and 5 by 2, it is 4 minus 2x, again a polynomial function. So this 4 is a constant, 2x is a polynomial function. Combination of these two will always be continuous. That is the difference will also be continuous. Between 5 by 2 and 4, it's 2x minus 7. Again 2x is a polynomial. 7 is a continuous function. So if one is f, one is g, f minus g, that is their difference will also be continuous. But here we don't have to check for 0 and 4 because it is not changing. We don't know about that. But by the question we know that in 1, the point where 1 is there and 5 by 2, it is changing. So we'll take x as 1 minus h, we'll take x as 1 plus h. So I'm talking about 1. So when you go back a bit from 1, you'll have to use 2 root x. I'm replacing x by 1 minus h. On the right hand limit, 4 minus 2x. So here I am replacing x by 1 plus h. So you can just take h as 0 here, under root 1 is 1. So 2 will be the answer. So limit h tends to 0, you can apply on both LHL and RHL. So 2 you get on LHL. On RHL, when you apply h as 0, you get 4 minus 2, that is 2. So the left hand limit and the right hand limit, they are matching. They are equal. So there is no problem with, so you can just remove all the options having 1. So the answer can be x equals 5 by 2, x equals 0 and 4. 0 and 4 it cannot be because we can see that it is not, but we have to prove it. So we have to check at 5 by 2. So left hand limit for this 5 by 2 is 5 by 2 minus h. Right hand limit is 5 by 2 plus h, RHL. We are checking at 5 by 2. So when you go back from 5 by 2, you are going to use 4 minus 2x. So 4 minus 2 into 5 by 2 minus h. When you go on the right of 5 by 2, you are going to use 5 by 2 plus h. So 2x minus 7 you have to use. So 2 into 5 by 2 plus h minus 7. So what do you get here? 4 minus 2 into 5 by 2 minus minus is plus, so plus 2h you will get. So this is going to be 0, 2 gets cancelled, 4 minus 5 is negative 1. Now multiply this, 2 into 5 by 2 plus 2h minus 7, so this goes 0, 2 gets cancelled, 5 minus 7 is negative 2. So minus 1 and minus 2, they are not equal. That means this is the point of discontinuity. So this is the answer. fx is discontinuous at x equals 5 by 2. Now we have here 3 functions. At pi by 2, it is a. It's already given as a. So we have to see the left hand limit and right hand limit at x equals pi by 2. That is how you are going to achieve b, because you want to have b. So let us take one by one. Left hand limit will take, right hand limit will take for pi by 2. And that is how we are going to arrive at the solution for a and b. So left hand limit for this pi by 2 minus h, x equals pi by 2 minus h, you are going to put. So 1 minus sine square a in place of x, replace it by pi by 2 minus h. The denominator, just replace it by cos square pi by 2 minus h. So cos 90 minus theta is sine theta, sine 90 minus theta is cos theta. Okay. So 1 minus sine square, it's basically cos square, 1 minus cos square h. In the denominator you have 3 cos square, because cos 90 minus theta is sine theta, so sine square h it will be. Now 1 minus cos square theta is sine square theta, because sine square theta plus cos square theta is equal to 1. So you can write it here as sine square theta divided by 3 sine square theta. Sine square gets cancelled, you get 1 by 3. Now this left hand limit and right hand limit are equal because it is continuous at pi by 2, so you can just equate it to a. So a is 1 by 3. The answer of a is 1 by 3. But before that, let me just do or take you to right hand limit as well. So what does this right hand limit says? Just see here. Right hand limit we have to put this pi by 2 plus h. So b into 1 minus sine pi by 2 plus h, and then we have pi minus denominator, pi minus 2 into pi by 2 plus h, and then pi minus 2 into pi by 2 minus 2h, so this 2 gets cancelled, and then you can have 4h square here. So this 1 minus sine 90 plus theta, it is add sugar to coffee. So this sine pi by 2 plus h is cos h. But since it is positive, sine is positive in the second quadrant, then what you are going to get It's going to be positive only. So you have 1 minus cos h, and then we have in the denominator 4h square. B by 4h square we are going to deal later. What you are going to get? 1 minus cos h, so it is 2 sin square h by 2. In the denominator, as I said, you already have h square, so you have to have a divided by 4, so you have to have a 4 to multiply also. So sin h by 2, h by 2, this is limit. If you apply, it is going to be 1, because sin theta by theta, limit theta tends to 0 is 1, so you get b by 8. Now b by 8 is equal to 1 by 3, this is equal to a, so from here you get b equals 8 by 3. And the earlier one, as I told you, the earlier one remember, it was a was 1 by 3. So you have a as 1 by 3 and b by 8, so a is 1 by 3, b is 8 by 3. This is your answer, second one. The points of discontinuity of the function fx is equal to, so this is x is less than or equal to 1, then x is between 1 and 3, and then x is greater than or equal to 3. So you have this as 1, you go back, you have to use this first function. In between 1 and 3, you are going to use the 6 minus 5x. On the right, you have to use the x minus 5. Okay. So the point of contention is basically 1 and 3. And all these three functions are basically polynomials. Okay. So let us try to find out at 1 and 3. These are the point of discontinuity or continuity. So this, we have to find out the points of discontinuity. So x is equal to 1. So we are left hand limit and right hand limit we have to take. When we take x as 1 minus h, it is going to be 1 by 5 into 2x square plus 3 we are going to use. So 1 by 5. In place of x, just replace it by 1 minus h. So 1 minus h whole square plus 3. So just put h as 0 because we can just apply a limit here. But for you have to open it. 1 minus h whole square, you have to open it and then you have to solve. Okay. So you get 5 by 5, which is equal to 1 here in this case. Now right hand limit. Let us find out the right hand limit. So as I told you, right hand limit, you have to use the second function, which is nothing but your 6 minus 5 into x. So 6 minus 5 into x, in place of x, right hand limit, 1 plus h you replace. Again h is 0, so 6 minus 5 is equal to, this is 1. So at 1 it is continuous because both left hand limit, right hand limit, they are 1. So now we are talking about the point which is 3. So discontinuity, see, first it is not discontinuous at 1. So first option, third option, and none of these. You can just eliminate these 3. So x equals 3 is the answer. But x equals 3, from the options, it is clear that x equals to 3 it should be, because x is not x1, 3, this cannot be true. None of these also is not true. But we will do the x equals 3 and we'll show that at x equals to 3 it is actually discontinuous. So let us see at x equals 3. So x equals 3 we are going to find out. LHL and RHL, left hand limit and right hand limit. So x equals 3 minus h will use, x equals 3 plus h you will use. When you go back a bit from 3, you have to use 6 minus 5x. On the right, you have to use x minus 3. So I am replacing x by 3 minus h in 6 minus 5x. I am replacing x as 3 plus h in x minus 3. So this 3 plus h minus 3, this, you said this gets cancelled, h is 0 already. So you have limit h tends to 0, just apply it. This is going to be 0 and this is 6 minus 5, 3, this is going to be 0, 5, 3 is a 15. So 6 minus 15 is a negative 9. The left hand limit, right hand limit, they are not matching. One is negative 9, one is 0. So x equals 3 is the point of discontinuity, is the answer. The value of a for which the function this one is continuous at every point of its domain is. So we have to find out a, and by far we have done already 40 questions. So you know how to do this. Left hand limit, right hand limit equated, you'll get a. So just for the sake of completion, LHL, RHL, at point 1 you have to check. So x has 1 minus h, x has 1 plus h on LHL and RHL. 1 minus h you have to replace it in 5x minus 4. 1 plus h you have to replace in 4x square plus 3ax. So I am replacing 1 minus h and 1 plus h respectively in left hand limit and right hand limit. Okay. So this you can just replace this h by 0. 5 minus 4 is 1. This is going to be 1. And here you can just take this h as 0. 4 plus 3. Again this is 0. 4 plus 3a. Or this 4 plus 3a you have to equate so that you get a. So because this is the point of continuity, LHL has to be equal to RHL. So here you get 3a equals 1 minus 4, that is minus 3, a is negative 1. A is negative 1 is the answer, this one. So the value of a for which this is continuous is negative 1. Okay, so in between 0 and 2, 1 is the point. Now if fx is equal to, this is first function is for x not equal to pi by 2. The other one is a constant, x equals pi by 2, it is k. So this is continuous at x equals pi by 2, then k is equal to. So what we will do here is, we will just try to find out the limit. Since it is continuous at x equals pi by 2, left hand limit and right hand limit are equal. LHL and RHL are equal because this is x equals pi by 2. So what you have to do is, you just have to find out the LHL or RHL, means actually the limit. Not LHL, RHL, but just the limit. And this limit has to be equated to k. So what you can do is, you can either replace x by pi by 2 minus h, it's up to you. Or replace x by pi by 2 plus h, it's up to you. I am going to replace x by pi by 2 minus h. So we have sine cos x minus cos x divided by pi minus 2x whole square. So as I said, you can take any of it, pi by 2 minus h and pi by 2 plus h. So this x equals pi by 2 minus h. Okay, pi minus 2 into, I'm replacing this denominator now. Pi minus 2 into pi by 2 minus h. This is twice into pi by 2, minus minus gets plus 2h. So only 2h remains. And since it is square also, it will be 4h square in the denominator. Okay, this is the denominator, 4h square. We'll be taking care of it, we will be using it. But the numerator is sine cos, and you have to replace it by pi by 2 minus h. Again, I'm just saying you can always take it as pi by 2 plus h. It's up to you. And we have cos pi by 2 minus h. Cos pi by 2 minus h is this cos 90 minus theta is sine theta. So sine h. So always write limit h tends to 0 everywhere, because this is what we are doing. Sine h minus cos 90 minus theta is sine theta. So you have sine h here. So in the denominator you have 4h square. But before that, this is sine theta minus sine c minus sine d. This is equivalent to sine c minus sine d. Now this c is sine h here, d is h here. So you can replace the sine c minus sine d as 2 sine c minus d by 2 and cos c plus d by 2. Okay. So this sine c minus sine d is 2 sine c minus d by 2 cos c plus d by 2. This is what we are going to use here. So this is going to be 2 sine h minus h by 2, sine h minus h by 2, and then we have cos sine h plus h by 2. Okay, so limit h tends to 0, you have to write everywhere. And what is in the denominator? 4h square. But you'll see this 4h square will have not much effect, because I'll just show you that this sine limit sine theta by theta is 1. So this is sine theta. Theta is what? Sine h minus h by 2. As I am saying, sine theta by theta, limit theta tends to 0 is 1. Okay. So sine h minus h divided by 2. This is theta. So we need a theta in the denominator. So when you have this denominator sine h minus h divided by 2, you have to have this in the numerator also, because you have introduced by yourself. So this sine h minus h by 2, this has been introduced. Now this is simply sine theta by theta. This is theta, sine theta by, this whole is, these both are theta. So sine theta by theta, limit theta tends to 0 is going to be 1, so I am just eliminating it. So 2 by 4h square, it is already there. You have cos sine h plus h by 2. So just leave it. Concentrate on sine h minus h by 2. So sine h minus h by 2, you can always write it as sine h by 2 minus h by 2. This is sine h by 2 minus h by 2. But again we can apply sine theta by theta. That is, I am talking about sine h minus h by 2. I am not talking about this cos term. I am just talking about the last term we have introduced. So sine h by 2 minus h by 2. Now when you apply the limit, you have to have a h in the denominator. And when we introduce h in the denominator, you have to have a h in the numerator also. Okay. So you can have a h in the denominator. But what you see here is sine h by h. H by 2 is still there. But you have sine h by h minus h by 2. Now if you take h by 2 common and apply the limit at sine h by h, it is going to be 1. So 1 minus 1 is 0. H by 2 you take, before taking the limit also, it is going to be 0. What I was suggesting you is this sine theta by theta we have already taken as 1. We have applied it. So we were having sine h minus h by 2, remember? I just told you about that. So this sine h by 2 minus h by 2, and when we introduce h in the numerator, h by 2 you can take common. Sine h by h, if you apply the limit, it is going to be 1. So when you take h by 2 outside, it will be sine h by h is going to be 1 for applying the limit. 1 minus 1 is 0. So you'll get a 0. So you don't have to worry about anything here. Okay? Because one term is 0, every term will be 0. This cos sine y plus sine h by plus h by 2 is not going to be 0, because cos, if you put 0 inside, cos 0 is already 1. So only this term we have to see about. And this has given you 0. So this k is equal to 0, because you have to equate it to k when x is equal to pi by 2. So f pi by 2 is k is 0. Okay, this question is a bit tricky. So I'll give you a hint. I want you to, put all your mind and effort here, but I'll give you some hint here that how to go about it. I'll give you the solution also. The answer is discontinuous only at x equals plus minus 1 by n belonging to z, that is the integer minus 0, and x is equal to 0. So plus minus 1 by n and minus 1 by n, this is what you have to see. Okay. But you have to understand, what does this mean? Mod x is greater than or equal to 1. Mod x is between 1 by n and 1 by n minus 1. This is the basic thing you have to actually talk about in this question. Okay. So let us see. Mod x is greater than or equal to 1. See, x is what? This x is greater than 0. If x is greater than 0, you get x. If x is less than 0, you get negative x. This is what you get. So mod x, mod x is greater than or equal to 1, that is either you are above 1 or below minus 1. That is, I'll give you another explanation of it, because this is very important. When you say mod x is greater than or equal to 5, mod x is greater than or equal to say n, what does that mean? What does that signify? That signifies that you are not taking the value in between the limits of negative and positive 1. So this mod x is greater than or equal to 0, because mod x is x and minus x. So minus x is greater than 1 or greater than or equal to 1, or positive x is greater than or equal to 1. So x is greater than or equal to 1, it is already there, the second one. But when it is negative x is greater than or equal to 1, when you multiply negative on both the sides, it will be the sign changing. So x will be less than, x is less than minus 1. So this is how it comes. X is greater than 1 and x is less than minus 1. This is how it comes. So when you're talking about x greater than 1 and minus 1, you have to use 1, the constant value. I hope you got the idea. So when you are below -1, you are going to use this constant. When you are above 1, you are going to use this constant 1. But what about values in between? Because we have mod x, which is also giving you mod x is between 1 by n and 1 by n minus 1. Okay. So mod x is in between 1 by 2. If you take n as 2, 1 by 2 and 1, because I'm putting n as 2. So when you remove this modulus, same as the discussion in mod x greater than or equal to 1. So you are in between -1 and -1 by 2. And on the right hand side, when you take, you are between 1 and half and 1. So if you can just take x one time and negative x one time, and you will see that you are talking about -1 and -half. This point, this is and this area, 1 and half. 1 and half. So this is the graph of this function. Now if you take this, see in bit, you have to use 1 by n square here when you are in between this. When you take 2, when you take 3 in place of, so there will be 1 by 3 and 1 by 3 minus 1, that is 1 by 2. So 1 by 3 is 0.33, 1 by 3 minus 1 by 2 is 0.5. So there will be another graph which I just showed you. Okay. Now, as I said, you have to take different cases here. Mostly what you see is that 1 by n square, when you replace it by 1 by n, when you replace it by 1 by n minus 1, it will be 1 by n square and 1 by n minus 1 whole square. So they are not going to match at all. So at plus minus 1 by n, it is not going to be continuous. That is what we see here. And at 0 also the same situation arises. Okay. So x equals -1 if you check. What do you get? I'm just trying to check so that we can say that, okay, we are not getting the continuity. So x equals -1. On left you go, x 1 minus, you'll get a 1. Because this is a constant. As I said, -1 below, you have to take 1. But when you are going above -1, so you have to follow this 1 by n square. So let us take this 2. So 1 by 4 it is. When you take x tends to 1, -1 plus, it is going to be 1 by 4. Because 1 by 4, that is, as I told you, it is -1 and half. -1 and -half in between that. So you have this 1 by 4 and 1, they are not matching, left hand limit, right hand limit. So it is not continuous. Now at x equals to 0, what are you going to do? At x equals to 0, when you go left and right, you have to use what? This 1 by n square, 1 by n square. So one time you put 1 by n minus h on the left hand limit, as we have been doing up till now. And on the right hand side, you take 1 by n plus h. In both the cases, 1 by n minus h and 1 by n plus h, you have to use it in 1 by n square. If h is 0, just replace, because left hand limit, right hand limit, it is h only. So if h is 0, you have to use 1 by n minus h I am using in left hand limit, 1 by n plus h I am using in the right hand limit. But because of this, mod x is between 1 by n and 1 by n minus 1, and you have to use the function 1 by n square. It will be 1 by n minus 1 whole square and 1 by n square. Because it is 1 by n square. One time you have to use 1 by n minus 1, one time you have to use 1 by n. Okay. So when you see that they are not equal. So at x equals to 0, it is discontinuous. So this thing will happen everywhere. If you take x as -1 by n, if you take x as positive 1 by n, if you take 1 by n, it will be again 1 by n and 1 by n square and 1 by n minus 1 whole square. Again, when you take plus 1 by n, it will be again 1 by n square and 1 by n minus 1 whole square. So they are not going to match at all, right? If you take mod x as 1 by n, that is x is -1 and 1, then 1 by n minus 1 whole square, 1 by n square, it always will be two things. No, it can never match. That is why it is discontinuous here also, plus minus 1 by n. So I showed you at 0, I showed you at plus minus 1 by n, I showed you at -1 also. So this is a very important question for those who are preparing for the engineering examination. Okay. So this is all about the discussion. Thank you so much and take care of yourself.